circuit the current through 5 millihenry inductor, all right, 5 millihenry inductor. Let me solve that. All right, so this is actually inductor, right. So in steady state is, right. Now focus on this. So steady state, all right. Now if you notice the circuit here, so you have a 5 ohm resistor, a 20 volt battery, and two inductors, right, 5 millihenry and 10 millihenry, they are in parallel, all right. So they are asking you what is the current that is flowing through the 5 millihenry inductor in steady state, all right. So what do we mean by steady state? So in steady state, when we speak about inductor, right, so inductor, it behaves as a short circuit, right. So here in steady state, we can replace these two inductors with short circuit. Does it mean that the current will get divided equally? Here we are ignoring the resistance of the inductor, all right. Now we shouldn't take it like that. Now let us try to see what happens when you turn on the, that is this will be the setup, okay. So initially say there is no current flowing through the inductors, then you will turn on the switch, all right, then the current will start flowing, that is we will analyze starting from the transient state onwards, all right. So how can we solve this question? Let us try to understand here. All right, so now I have two inductors, right, fine. So in steady state, right, so in steady state the inductors will start behaving like short circuit, correct. So it will help me in getting the total current flowing through the circuit, right. So these two are short circuited, right. Now you have the current I, let me say the current is I, all right. So I, and say current flowing through 5 millihenry is I1, then current flowing through 10 millihenry is I2, all right. So I1 and I2, so these two are short circuits, right. So if you consider the complete circuit, so you have just a battery and the resistor in the steady state circuit. That is how it behaves, because these two inductors are acting like short circuits, correct, fine. So therefore the current, right, so I'll write it as the potential difference, which is 20 volts divided by the resistance, which is 5 ohms. So I'm getting it as 4 amperes. All right, I'm getting it as 4 amperes. Now if you observe the inductors, these two inductors are in parallel, right. So therefore the potential difference across both of them will be same, right. So that is even in the transient state and in the steady state, right. So that is why I'll write V is equal to L di1 divided by dt, or let me say okay, I1 will say, okay. So I1, don't take it as a constant current, okay. So remember I'm talking in transient state as well as in the steady state, right. So this is L1, L1 is 5 millihenry, L1 di1 divided by dt, that is also equal to L2 di2 divided by dt, right, L2 di2 divided by dt, fine. Okay, now what I can do is, let me take 5. So this is 5 millihenry. So let us keep milli as it is. I am considering milli only here, all right. So dt and dt you can get it will get cancelled. Now di1, right, 5 di1 is equal to, now I can write 10 di2. Now how do you think this I1 and I2 will vary? So they will increase, right. So LR circuit, sorry, yeah, LR circuit only, right. Okay. So finally what you can do is, you can integrate this and take the limits from 0 to I1. Now you can treat this as a dummy variable. Now here also you have to take it from 0 to I2. Okay. So finally if you integrate, I am getting 5I1 is equal to 10I2. All right. So finally 5I1 is equal to 10I2 I have. Otherwise I can say I1 is equal to 2I2. Correct. So I1 is equal to 2I2 also I have. Now from this figure, I1 and I2 if I add, correct. So I1 plus I2 if I add, I am getting it as 4 amperes. So using these two, I need to get I1 first, okay. So let me substitute for, yes, I1 I need to get, alright. So let me substitute for I2 here, okay. So I2 is equal to, I can write it as I1 divided by 2. So in place of I2 I am substituting I1 divided by 2, that is equal to 4, okay. Now I have 3I1 divided by 2 is equal to 4. So obviously I1, it is going to be 8 divided by 3 amperes, okay. So this is the current flowing through the 5 millihenry inductor, all right. So the correct answer would be 8 by 3. So this was a single choice, okay, single correct. This was a single correct question, all right. So this is the answer. Hope there are no doubts. Fine. So let us go to the next question. So this was also a single correct answer. Fine. So let us go through it. A spool of mass m has inner and outer radius r and 2r respectively. A thread is wound on the inner disc and its free end is pulled with a force F. Alright, fine. At an angle theta with the horizontal in the direction as shown in the figure. Assume no slipping condition for thread and the spool and ICM, that is moment of inertia, about the center of mass. They have given it as 2 mr square. Okay. Then the options, the diagram is like this. As you can see, force F is this way. Alright. Now this is the angle. So theta, correct, and the inner radius, right, it is taken as r and the outer radius is 2r. Now here is where you have wound the thread. Alright. Okay. Now the options are like this. Now for theta between 0 and 90 and equal to, that is equal to 90 and equal to 0 and 90, and between those values also, frictional force acts leftward only. So this is the first option. Now if theta lies between this 0 and 60 degrees, including 0 and 60, it acts leftward, and they have given for 60, if it lies between 60 and 90 degrees, including both the values, it acts rightward. Then for a certain angle between 0 and 90, friction becomes 0. Direction of friction cannot be concluded with the information of theta. This is what they have given. All right. So let us try to see. Let us try to get. Now here, if you remember, if you can see, right. So if you see the options, you have to get an expression. You have to try to relate, right. You have to get the expression for friction considering this theta, right. You must have an expression consisting of this theta also. What is theta? Theta is the angle made by the force, right. Force with respect to the horizontal. All right. So let us see what we can get here. All right. So let me sketch a rough diagram here. So this is the spool, right. Now say this is the center. All right. Now they have given this radius as capital R, this radius as 2r. All right. Now this is the horizontal, right. Now the force F is acting like this. Now this is the angle theta. Okay. Now here is your ground, and they ask you no slipping, right. So no slipping. Fine. Now what are the forces acting? Let us try to understand here. So the thread is wound here. Okay. Right. So when you start applying the force, right. Now say the motion is this way. Okay. Say the spool will start moving this way. How is that? How can you say? Because see here, when I start pulling this, right, when I start applying force like this, you will be getting, you can consider two components of the force. What is that? F cos theta and F sin theta, right. So F cos theta will come here and F sin theta will come here, correct. Now if you notice on the forces, right, I can say F cos theta, correct, minus frictional force. What friction is this? This is the static friction, correct. So F cos theta minus the static friction, that will be equal to m into A. So here A stands for acceleration of the center of mass. Okay, so A it is for the acceleration of the center of mass, as you know, right. So next what I can do is I can consider torque also, correct. I can consider torque also. So if you consider torque, fine. So next, yeah, so I can say F into R. Now if you observe F into R, what is the overall, if the spool is trying to go in this direction, so we can take the angular acceleration alpha, it is in the clockwise direction as per this diagram here, correct. So if I consider the torque, now I have this F, right. So F is trying to, overall the motion is clockwise only, right. So F, first let me consider the torque due to friction now, right. So F, right, into 2R, see, about the center of mass I am taking, okay, torque about the center of mass, right. Now minus F into R, right, minus F into small r, right. So no, torque is force into the distance, right. So the perpendicular distance, so which was 2r here, right. So this is F and its distance is r, right. Okay, so that will be equal to, now I have to consider the angular acceleration, correct. So now I will write it as I alpha, okay. Right. So torque is force is equal to ma, right. So same way we are going, net torque is equal to I into alpha, we will write, okay, fine. All right. So next what we can do here is let me substitute for this I, okay. So, F into 2R minus Fr is equal to, now I they have given it as 2mr square, correct. So, they have given it as 2mr square. So, 2 small m r square alpha, 2m smaller r square, yeah, r square alpha, this is right, okay. So, next I can cancel capital R, correct. So, after cancelling capital R, I am getting 2f minus f, okay. So, thus that would be equal to 2mr alpha, 2mr alpha, right. Now, let me highlight these equations. What is our objective here? What is our goal? We have to get an expression for friction, right, get an expression for friction with a term, right, with, or you can say something, theta must be present in the equation, right, equation for this friction. So, highlight this and let me highlight this. All right. So, next let me consider the relation between linear acceleration and this angular acceleration alpha, correct. Now, what do we know? So, alpha, right, here I am trying to define with respect to the center of mass. So, A, right. So, A, you know, we'll write it as R alpha, correct, we'll write it as R alpha. Now, in this case, right, in this case, since I am talking about the center of mass, right, and here I will consider the radius as 2r, correct. So, 2r into alpha. Now, let me substitute for 2r alpha, otherwise I can say 2r alpha as A, correct. So, therefore, this equation I am going to write again. So, 2f minus f, okay. So, that will be equal to 2mr alpha. Now, for 2r and alpha, I can substitute A, right. So, therefore, 2f minus f is going to be ma, okay. I am going to get it as ma, fine, all right. So, next what I can do is I need to get an expression for friction here, right. Okay, so I think I have these two equations, right. So, if you can see here, I have equation 1 and I have this equation 2, correct. Now, since the LHS is same, right. So, since LHS is same, I can equate the RHS. There are many ways to do this again. So, 2f minus f is just need to get an expression where friction can be expressed in terms of the angle, this angle theta, correct, fine. So, I can say 2f minus f is equal to f cos theta minus f, right. So, f cos theta minus small f, okay. So, bring it this way, right, you are going to get 3f is equal to f plus f cos theta, correct, yes. F plus f cos theta. So, I can take f common. Now, you are going to get 1 plus cos theta, correct, 1 plus cos theta. So, naturally f is equal to f into 1 plus cos theta divided by 3. Now, see here you have an expression where in the LHS you have friction, in the RHS you have the force that you have applied, and that is all right. So, rest all are constants, the force F that you are applying and the angle made by the force with respect to horizontal, which is theta, right. Now, for any angle between 0 and 90, see in this, as per this particular diagram, the only possible way, right. So, they are giving theta with respect to the horizontal, right. So, you can take it from 0 to 90, correct. So, 0 to 90, right. So, for any angle theta here, correct. So, cos 0 if you put, still f will be positive. Now, what does that mean? See here, when we wrote equations, I have already considered the direction of f. For example, f cos theta was to the right and small f, right, friction, static friction, it was to the left, right. So, obviously, the direction of f is decided in this expressions, equations, whatever we have written, correct. So, for any angle, right, for any angle theta, you will see that f always remains positive, right, f always remains positive. So, therefore, the friction will act only, I'll write it here, it will act only in the leftward direction, okay, it will act only in the leftward direction, okay, fine. So, if you substitute, yeah, I think you will get some other expression for this f if you solve in your own way. So, this is also right, okay. Nice. So, this is the expression that I have got, all right, and for any angle theta, you will see that friction, static friction will be positive, okay, fine. At least from this expression, that means its direction, right, it is to the left only for any angle theta, all right. So, let us go to the next question. Yeah, so the correct option was only option A, okay. So, this was also single correct, all right. So, next Yeah, so this is multi-correct, more than one option. Okay, more than one option. Fine. Okay, so let us go through the question. It says an object A is kept fixed at point x is equal to 3 and y is equal to 1.25 meter on a plank P raised above the ground. At time t is equal to 0, the object starts moving along the x direction with an acceleration of 1.5 meter per second square. Okay. At the same instant, a stone is projected from the origin with a velocity u. Okay, with a velocity u. A stationary person on the ground observes the stone hitting the object during its downward motion at an angle of 45 degree, right, to the horizontal. All the motions are in xy plane. So they have asked you to take g is equal to 10 meter per second square. All right. So let us see how to solve this problem. So let us put the problem in the form of a diagram now. Okay. So this is our xy plane. Fine. So first they are saying you have a object, right, which is kept on a plank P raised above the ground, right. So which is at x is equal to 3 meter and y is equal to 1.25 meter. So 3 and 1.25 somewhere here. Okay, somewhere here. So you have this object. Now say this is the plank, right, and you know that the object and the plank, say both of them are sticking to each other, and the acceleration is 1.5 meter per second square, right. So when is this acceleration? When we should consider this acceleration, we'll see that. All right. Next, at the same instant, so at t is equal to 0, this particle, right, this plank and the particle, it will start moving towards the right with that acceleration of 1.5 meter per second square. All right. Now at the same time, what you are doing is, okay, so like this. Okay, like this. So this will start accelerating, and you will start throwing a stone also. Okay, fine. Now, yes, next, stationary, yes, you are projecting a stone with some velocity u. Okay. Now, next, if you read it, a stationary person on the ground observes the stone hitting the object during its downward motion at an angle of 45 degrees. When is this? At downward motion, correct? So the path, right, the path, if you consider, it will be like this, correct? So here the velocity at this point, right, the velocity at this point, it is going to make 45 degree to the horizontal. Downwards also they have given. So this is the clue. Okay, this is the clue, right, and say this is the angle of projection. Okay, so this is the angle of projection. Let me call it as theta here. I think the problem is clear. Whatever we have in the problem, I have put it in the form of a diagram. That is all. I have not solved it yet. All right, fine. Then they're asking you to consider all the motions in the xy plane only, right? So these are the options given. The time after which the stone hits the object is 1 second. Relative acceleration between the object and the stone is non-zero. Okay. Then during the motion, relative velocity becomes horizontal at one instant. Only at one instant. All right. Next, the angle of projection with horizontal angle of projection. Which one is that? Theta. Okay. This angle is 45 degree. It is angle with which it hits the velocity, with the angle made by the velocity with respect to the horizontal level, right? That is what they have given, 45 degree to the horizontal. Don't take it as 45 again, right? Okay, they're talking about angle of projection here. Fine. Okay, so let us try to solve this now. All right. So next, yes. So let me consider this. Fine. All right. Now, how do we approach this? Yes, so the coordinates, right? So the coordinates they have given it as, how much is that? 3 meter, comma 1.25 meter. Okay, 3 meter, comma 1.25 meter, right? Now let us talk about the y coordinate first. Okay, so x coordinate is 3 meter at t is equal to 0. So this is the situation at t is equal to 0. Okay, right. Now, fine. Okay, so let us consider the y coordinate first. Let us consider the y coordinate. Okay. Now what happens to the y coordinate of this particle? It remains the same, right? Because all you can see is that its height, right? Its height is always 1.25 only. Okay, its height is 1.25 only, right? Now y coordinate, it is always going to be, that is, if I talk about the object, right? So this is the object and this is the stone. Okay, so stone is here and the object is here. Okay, so if I consider the object, it is always going to be 1.25 meters. Now, what happens when the stone hits the object after some time? Its y coordinate is also going to be the same, right? Okay, so therefore, let us take the y coordinate of the stone, that is, say, after t seconds, right? That is the time which we need to find, because the first option they are talking about time. Okay, so let me write like that. After t seconds, comma, the stone. Now this t is the one we need to find. Okay, the stone hits the object. Okay, it hits the object. Let me take it like that. Fine. So 1.25. So let me write the equation first. Y is equal to, UYT will say, right? Y is equal to UYT, okay, plus half AYT square. Okay. So this y, right, at some time t seconds, the stone hits the object, means what should be its y coordinate? I am just talking about y coordinate now. It should also be the same 1.25, right? So therefore, I will write 1.25 is equal to uy. So I will write it as u sin theta t. Okay, u sin theta t, then plus half. Ay is nothing but, acceleration in the y direction. It is in the negative y direction, right? So which is 10. So I'll write it as minus half into 10 into t square. Okay, so therefore I'm getting 1.25 is equal to u sin theta into t. Okay, then I can write minus 5t square. Let us keep this equation here. So next, let us try to get the x coordinate. Okay, see, at time t is equal to 0, the object was already, its x coordinate is already 3 meters. Okay, its x coordinate is already 3 meters. Now if you consider the object is done, right, at t is equal to 0, its x coordinate is 3 meters. Now after t seconds, right, after the same t seconds, the stone's x coordinate must also be the same 3 meters. Okay, what is its initial x coordinate? 0. It started from origin, let us say. Okay, so let us talk about x coordinate now. Let us talk about x coordinate. Now I have, so object, right? Now, so after t seconds, right? So initially it was at 3 meter at t is equal to 0. Yeah, this is right. Okay, 3 meter at t is equal to 0. Now the same object I need to find where it will be at t seconds. Okay, so at t seconds, because it is moving to the right, correct? It is moving to the right. Okay, so what I will do is, okay, so so its initial displacement, correct? So x coordinate, right? Okay, so I'll write x is equal to, I'll write like this. So initially it was at 3, right? So x is equal to 3 plus, so 3 plus half. So now I'll use, so initially at t is equal to 0, its initial displacement x coordinate is 3 already, right? Now after t seconds, right? So where do you think it will be? So it will be half into a into, now this is ax actually, correct? Ax, because it is moving in the x direction. So into t square. So therefore I am going to get it as x is equal to, okay, x is equal to 3, okay, plus half into ax is 1.5 t square. Okay, x is equal to 3 plus half into 1.5 t square. So this I am getting it as x is equal to 3 plus 0.75 t square. So let me write it there. All you have to do is just get a bunch of equations, all right? So then we should try to get the relation between them, that is all. Okay, fine. All right, so y coordinate is done and x coordinate is done. All right, now next, let me try to, so fine. Okay, so after, just a second, let me refer my notes, because it's easy to solve in notes compared to I have to keep switching back between the slides. All right, so initially this is how it is. Yeah, okay, so then, yes, now let me talk about the projectile now, right? Object I have written, yes. Now next I have to consider the stone, right? So stone, now what do we know? So here the stone is projected with some angle theta here. So you can resolve it into two components, ux and uy. So uy I have considered here, u sin theta, right? Now at this time t also, now you can say also this x is equal to, now I have ux into t in the same time t, right? In the same time t at t seconds, this stone is meeting the object, correct? So therefore I can say ux into t, correct? Also x is equal to ux into t. So I'll write u cos theta into t, yeah, so this is right, okay, u cos theta into t, that will be equal to 3 plus 0.75 t square, okay, so 3 plus 0.75 t square. Now if you observe, we have equations here, right? So u cos theta t I have. Now let me write for u sin theta t. What can I write for u sin theta t? U sin theta t is equal to 1.25 plus 5 t square, okay. So let me consider this, then u sin theta into t, that is going to be, yeah, so 1.25 plus 5 t square, 1.25 plus 5 t square. Yes, here I have these two equations, so we are getting somewhere, okay, nice. So next let us see the information, other information they have given, which will help us to solve the problem. Yeah, now finally they have said when it hits, right, when the stone hits the object, correct, yeah, stone hitting the object, it makes an angle of 45 degree with respect to the horizontal in the downward motion. So what we'll do is, we'll try to resolve the velocity now, right? Okay, so tan theta, correct? So tan theta, we'll write it as Vy by Vx, you remember, right? So during, this is the projectile motion, let us say, okay? So this is where it hits, so this is your V, okay? Now resolve it, right? So if you resolve, you are getting Vx and this is your Vy. Okay, this is your Vx and Vy, that is what I am writing, tan theta. So this theta with the horizontal, angle made by the velocity with the horizontal, it is Vy minus Vx. Now they have given it as it is 45 degrees, so you are going in the clockwise direction. So take it as tan of minus 45 degrees, that is going to be Uy. So V is equal to U plus AT will use. So now we have Uy minus 10t gt, right? So 10t divided by Ux. Sorry, this is, yeah, so what is Vx? Vx is Ux only, right? Throughout the motion, Vx is equal to Ux only. I am talking about stone, this is for stone, okay, I am talking about stone here. Stone is the one which is in the projectile motion, correct? So moving on, now see this here. So I have minus 1, that is equal to u sin theta minus 10t, okay, divided by u cos theta. U cos theta, okay, fine. So let me get an expression from that. All right, now I have u minus u cos theta, correct, that is equal to u sin theta minus 10t, okay. Finally what I can do is u sin theta, right, so if you transpose u sin theta plus u cos theta, okay, u sin theta plus u cos theta is equal to 10t, right, okay. Now I have all the necessary equations that I need, all right. Okay, now if you observe these three equations, this one, this equation, these two equations and this equation, what I can do is, let me multiply t thoroughly into this equation, okay. So if I multiply t thoroughly, I'll get u sin theta t plus u cos theta t, right. So u sin theta into t plus u cos theta into t, okay. So that is going to be 10t square, okay, that is going to be 10t square. Now this is easy. Now I have an expression for u cos theta t and u sin theta t. What is that? 3 plus 0.75 t square. So 3 plus 0.75 t square, okay. Now u cos theta t, it is, okay, so u cos theta t, I have written this 3 plus 0.75 t square, okay. Now for u sin theta t, I have to write 1.25 plus 5 t square, okay, 1.25 plus 5 t square. Hope this is right. Yeah, 3 plus 0.75 t square. Okay, very nice. So this was actually u cos theta and this is actually u sin theta, I think. Yes, that is right. So finally I have 10t square. Now as you can see here, that is the only unknown is t square here. Now upon solving, you will get that t is equal to 1. Okay, so t is equal to 1 second. Fine. Now let us try to go to the options and see which of them are correct. All right. Now the time after which the stone hits the object is 1 second they have given. So this is right. Okay. Now relative acceleration between the object and the stone is non-zero. Do you think it is right? Obviously, because we know that this object, right, it is always having an acceleration. Okay, it is always having an acceleration of 1.5 meter per second square. Correct. So that is like this. This is acceleration of the object, right? Now acceleration of the, what do we know? Acceleration of the stone, right? Now we know the only force that acts on the stone is gravitational force. Now because of that, it will be having acceleration like this, right? So a naught, or you can say just take the difference, right? So these two are vectors. Take the difference. If you take a naught minus ay, so minus ay is going to come here, right? So you will have some finite relative acceleration, correct? Relative acceleration is also there. Okay, it is not 0. It is some value. Okay, they have given non-zero, right? So it is some value which is not 0. Okay, nice. So B is also right. Next, during the motion, relative velocity remain horizontal at, yeah, so only at one instant. Okay, relative velocity they are talking about. Okay, yeah, this is true. When is that? Because if you try to analyze the motion, correct? If you try to analyze the motion, so this is what you are going to get. Now this body, as you can see here, object, right, O for object, its velocity is always this way. Now since it is accelerating in the right, okay, the magnitude of the velocity will increase, right? However, the direction is the same. Okay. Now if you talk about the projectile of the stone, right, if you talk about the stone, right, so you know its velocity is given by the tangent drawn at that particular point, only at the topmost point, right? So its velocity will be like this. Now it is at this point, okay, it is at this point you will find the relative velocity, correct? The relative velocity remains horizontal at only one instant. That is true. Okay, that is true. Fine. Okay, so option C is also right. Next, angle of projection with horizontal is greater than 45 degrees. Okay, so this is what they are saying. Now I need u, right? So if I need angle of projection, how do I get it? So it's quite simple. Now let me come back to this diagram here. So this was your initial velocity. Now I have ux, I can resolve it into ux and uy. Now the angle of projection, right? So I know tan theta, I can write it as uy divided by ux, correct? Now uy, how can I find out? So uy, I can get it from this equation here. So t I have, correct? So t I have here. Yes, t. If I substitute for t, you will get u sin theta and u cos theta also. I think from this equation also you will get an expression for yes, so this one. Okay, yes, so here you substitute 1 and 1, so you will get u cos theta, correct? Now you can clearly see u cos theta is equal to 3.75. Okay, now u sin theta, it is nothing but after substituting 1, okay, 1 and 1, you are getting it as 3.75 and 6.25, correct? So clearly uy, right? So uy is greater. Uy is greater than ux. Okay. So obviously tan theta, correct, is going to be greater than 1. So obviously theta is going to be greater than 45 degrees. Correct? Theta is going to be greater than 45 degrees. Alright. So finally it is horizontal is greater than 45 degrees. Okay. So such a long problem, right? So solving it on paper is always easy, right? So instead of switching it like this, okay, nice. Hope you got the answer, all of you. All right, so let us proceed. So all the options, right? All the options A, B, C, D, all of them are correct. Okay, right. So let us come to this question here. So this is also more than one correct option. Okay, you have more than one correct option. All right. So let us see what is the question. It says a rod of length L is rotating in uniform magnetic field as shown in the diagram. Also, PQ is equal to QR. They have given PQ is equal to QR. So Q is the midpoint. Okay, so Q is the midpoint. Then mark the correct option. So A, B, C and A are given. A says induced EMF between P and Q will be less than that between Q and R. Okay, so they have given EPQ is less than EQR. We'll see. Induced EMF between P and Q will be greater than that between Q and R. Okay, so they have given EPQ is greater than EQR. So this says EPQ is less than EQR. Okay, EMF. Okay, nice. So, and in C and D they have given the ratio E PQ by QR is 1:3. Now, here in this opposite case it is E PQ by QR, this has to be 3:1, I think, yeah, sorry. So, this has to be 3:1, okay, nice. So, let us try to solve that. Alright, now this is a rod which is rotating in the uniform magnetic field, right. So, this way, okay, nice. Now, let me sketch a rough diagram here. Alright, so this is the length of the rod. Let me say, yeah, so they have given the length of the rod as L. Okay, let me take the rod's length as L. Alright. So, if you consider the circular motion of the rod, right, about one of its ends, so obviously it is going to be, you can say, yes, so the length of the rod itself is nothing but the radius of the circle, correct. Now, magnetic field, it is this way, okay, nice. Nevertheless, we just need the magnitude of the EMF, right, okay, nice. Now, what I am going to do is, first, as you can observe from the question here, right, I need to get EMF between P and Q and Q and R, and I need to compare them. That is what I have in these 4 options, right. So, therefore, I have to find a way to find the EMF between any 2 points on the rod, right. Now, for this, we will take the approach of calculus here. Now, what I will do is, I will take a small elemental length dx, okay. So, let me take it as dx, okay. Now, say its distance, right, the elemental length distance from the center, that is the left end of the rod, right end of the rod, it is going in circular path, right, okay, left end of the rod is fixed. Let me take that distance as x, okay. Now, EMF induced, correct. So, let me take it as dE, okay. So, dE, so that will write it as, you know, magnetic field is like this, okay. Now, the velocity, right, the velocity you can take it like this, correct. The velocity, it will be like this, correct. So, V and B, V is like this, B is like this, perpendicular to each other, okay. So, dE, I can write it as B LV, magnetic field, length of the rod and velocity, right. Now, if you consider this small section, I can say B dx into V, okay, B dx into V, alright. Now, yes, now for this V, right, I can substitute omega r, correct. They have given it is revolving with constant omega here, correct. So, constant omega. So, omega, let me write. So, V I can write it as, remember V is the velocity of this elemental length dx that I have taken, correct. So, V I will write it as omega x, correct, omega into x, right. Now, let me substitute that there. So, dE I am going to write it as B dx, okay, then V is nothing but omega x, sorry, I am going to write it as omega x, okay. Now, you know that omega is constant, B is constant, okay. So, x and dx are there, right. Now, let me take the integration now, alright, okay. So, E if I need, that is EMF between any 2 points, okay. So, then I will integrate this dE, okay, dE I will write, then I have B omega, then integration of x dx, correct. So, B omega x dx, now that is all. So, you have an expression now, right. So, you have an expression, right. So, E after integrating I have B omega now x square divided by 2 between the limits now, okay. So, between the limits you have to take, alright. Now, if I talk about the limits from P to Q, okay. So, P to Q, what can I say? That is B omega, right, then x square by 2, right. So, x square by 2 between the limits, now P and Q, right. So, this is P is at 0 only, now Q is at L by 2, right. So, let me put it that way. So, 0 to L by 2, right. So, this is what I get. So, finally, I have B omega, now I have L square divided by 4, right, and you have a 2 there in the denominator also. Now, I have BL square divided by 8, okay. I hope this is right, okay, nice. So, next EQR let me take, okay, that is between these two, okay. So, EQR, same thing, just the limits will change now, right. So, just the limits will change, right. So, B omega x square by 2, right. So, B omega x square divided by 2. Now, the limits are from L by 2, right. So, Q to R, I will take L by 2 to L, okay, I will take it from L by 2 to L, alright. So, this would be from L by 2 to L, right. Now, I have B omega L square divided by 2 minus, right. Now, when I substituted L by 2, I got this B omega L square by 8. B omega L square divided by 8. Okay. Now, after you simplify, I think you are going to get, so 8 minus 2, 6, okay, so 3 by 8 we are going to get, correct. So, 3 divided by, yes, that is right. So, 3 divided by 8 B omega L square, that is all, right. So, 3 divided by 8. Now, let me take the ratio, okay. If you take the ratio EPQ, if you observe EPQ and EQR, correct. Now, which one do you think is greater? So, this is just 1 by 8, this is 3 times of 1 by 8, correct. So, EQR, right, EQR is 3 times EPQ. Clearly, you can make out, correct. So, obviously, 2 of them are right here. What is that? EQR is greater than EPQ, this is right, okay, and EQR divided by, so EPQ by EQR, right. So, that is 1 by 3, right. So, A and C are right, options A and C are right, okay. So, this is the correct answer, A and C are right, okay, right. So, let us go to the next one, fine. So, it says a solid cylinder of mass m and radius r is rolled horizontally on a rough surface as shown in the figure. Choose the correct statements, okay. Now, you have to get a bunch of equations and you have to try to get this. Acceleration of center of mass, you have to get it. Then acceleration of center of mass, they are saying it is 2 by 3 into F by m. Then the friction on the cylinder always acts backwards, they are saying, okay. Then the friction is F by 3, they are saying, okay. So, let us try to find that, okay. So, next, all right. Now, yes, solid cylinder, right? Yeah, solid cylinder they have given. Now, you need to find its, okay, fine. So, let us take the, let's sketch the rough diagram. Now, this is a solid cylinder, correct. Now, the force is acting exactly on the center of mass, right. Then, rough surface they have given, okay. So, obviously, they want you to consider the static friction here, correct. So, F is like this, okay, F is like this, right. So, next I can write F minus, correct. Now, obviously, the cylinder is going to accelerate this way, right. So, F minus F is going to be m into A. Now, here A stands for acceleration of center of mass, okay. A stands for acceleration of center of mass, all right. So, next what can I get? So, clearly you can see the acceleration of center of mass is not F divided by m. So, A is ruled out, correct, A is ruled out, right. So, next let us see what we can get, all right. Now, let me get the torque now, okay. If I try to get the torque, now, so alpha, so let us talk about torque here, right. So, tau is equal to I alpha, correct, right. So, tau, right. So, tau I can also write it as F into R, correct. So, F into R is equal to, now they are talking about this solid cylinder, right. So, I will write it as radius, they have given it as R, right, mass is m, okay, nice. So, next I am going to write it as m r square divided by 2. This is a solid cylinder, right, solid cylinder, m r square divided by 2 into alpha, correct. So, I am going to write it as alpha, fine. Now, if you observe this, r and r will get cancelled. Now, I have F is equal to m r alpha divided by 2, okay. So, F is equal to m r alpha divided by 2, okay, m r alpha divided by 2, okay. Now, next, so also if you consider the relation between angular acceleration, correct, angular acceleration and linear acceleration. So, what do I know? A I can write it as r alpha, correct. Angular acceleration is alpha, linear acceleration is A, right. Now, in place of r alpha, I am going to substitute A. So, F is equal to ma divided by 2, right. Now, see which equation we can use to get the expression for, they are asking there, we need to get the acceleration expression first, right. Okay. So, so in place of F, right, fine, let me use this equation F minus friction is now ma by 2, correct, that is going to be ma again, correct. Okay, I think I got this one, okay. All right, so for MEA, let me substitute 2F, okay, so that would be better instead, all right, because I need an expression for F, right? Okay, fine. So F is equal to MEA by 2, I have it here, so let me write it there. F is equal to, so let me substitute it here, MEA by 2. Now in place of MEA, I am going to write 2F, yeah, this would be better. Okay, so now I have F minus the friction is equal to, now MEA is equal to 2F, okay. So that I am going to write it as 2F here, okay. So obviously, you are going to get, okay, I think I need friction also here, right? Fine, okay, friction, yeah, option D is there, all right. So F is equal to 3F I have, so obviously, friction will be equal to F by 3. Now if you observe, option D turns out to be right, correct? Option D turns out to be right, okay. Now let me try to get the expression for acceleration now, okay. Now what is this F here? Okay, so if I get F and yeah, so let me get for F now, let me substitute for F, F is equal to, yes, now I can get the expression for F, right. So F minus, now F is F by 3, now this is F by 3, I am using this equation, okay, that is going to be equal to 2F, okay, that is going to be equal to 2F. Now I also know that small f, that is friction, is equal to MEA by 2, okay, so this is going to be 2F by 3 is equal to 2 into MEA divided by 2, yeah, so there you have it. You can get the expression for acceleration, see. So I can write A is equal to 2F divided by 3M, correct. So I have 2 by 3 into F by M. I hope this answer is there. Yeah, so 2 by 3 into F by M. So option A is not right, okay, A is not right because we got the acceleration of center of mass as 2 by 3 into F by M, okay. Then the friction on this cylinder acts backwards, this is also right, because the force is acting like this only, okay. So if friction was not there, this cylinder wouldn't have revolved, you know that, right? Okay, now finally, yeah, so C is also right. Then the friction is F by 3 like we calculated here. Yeah, I think I got the expression for friction first, then for the acceleration, okay. Yeah, finally B, C and D, right. So these options are correct, A is not correct, okay. Hope you are getting this. All right, so let us go to the next question. Fine. All right, so this is interesting. Now the following histogram represents the binding energy per particle, okay, per nucleon we'll say, right, in mega electron volt as a function of the mass number A of a nucleus. Which of the following statements are correct? Okay, nice. So the statement is, the options are given here. If a nucleus of mass number 140 splits into two nuclei of equal mass, okay, an energy of 560 mega electron volts is released, okay. So like that they have given. Next option they have is two nuclei of mass number 20 and 40 combined, an energy of 280 energy of 280 mega electron volt is released, like that, okay. Now next, if two nuclei of mass number 20 and 50 combine, an energy of 100 mega electron volt is released. Then finally, yeah, so these are the options. Next one we have to check option by option, okay. So next let us start with option A. All right, now they have given a nucleus of mass number 140 splits into two nuclei of equal mass and energy of 560 mega electron volts is released, okay. Now we have this 140, correct, it is splitting into two nuclei of equal masses they are given, right. So 70 and 70, okay, 70 and 70, right, okay. Now obviously some energy will also be released, okay. So this energy they have straight away given it in the graph here, right. So energy they have given it in the graph, right, okay. Now you know binding energy, it is related to the mass defect, right. Now how do we find this out? So 140, now if you observe, so this is the energy, right. So energy, binding energy per nucleon. So 0 and 20 you have 2, that is, this is in mega electron volts, right, 2 mega electron volts for one nucleon, right. So for one nucleon, right. Now next, for 20 to 40 it is 4 mega electron volts per nucleon. Then this goes from 40 to 80, right. So the range, if the, this is actually yeah, mass number, right, okay. So this is actually the mass number, fine, okay. So let us proceed here. All right, so 140, let me see what is the binding energy here, right. So 120 to 200 if you observe, right. So it is actually, yeah, so I think it is 4 only, okay. So let me take All right, so this is 4. Fine. So 4, right? Now I have 4 into 140. Okay, so 4 into 140, correct? So 4 into 140, I have it already. Then minus, okay, so this is the binding energy for that bigger nucleus, right? Okay, now you have these two nuclei, 70. If you look at 70, now you have 40 and 80, right? So here you have 8 now, correct? Right. Yes, so that is right. That is right. Okay, fine. Now I have 8 into 70 minus 8 into 70. No, something's wrong. 1 second. Yeah, so 8 into 70. So these things you need to, yeah, plus this is the energy liberated, correct? I hope I'm right. Just a second. Silly mistake. Yeah, the first one is, oh sorry, first I need to take the react. Okay, so whatever I get first, this one. All right. So yeah, so these are the ones that are released, right? Okay, just a second. Energy released, right? So energy released. So let me take it like this. Now this is 70 into 8. Okay. Now these are the products, right? After disintegration, this is what you are getting. Now next you have 70 into 8. Okay. Then finally you have 140. That is, yeah, 140, and this is actually 4. Okay. So 140 into 4, right? Okay. Now 56, 560 plus 560 minus, now you have 560 again, correct? So this is again 560. So obviously the first answer there, whatever you are getting is right. Okay. So 560 mega electron volts energy, right? It is actually released. See, this one will get cancelled, right? So option A looks to be right. Okay. So now let us see for option B. What are they saying? Option B, if two nuclei of mass number 20 and 40 combine, an energy of 280 megavolts is released, they are saying. Okay, it is released, they are saying, right? Okay, so 20 and 40, let me take that. Now you have 20, okay, then you have combining, right? So then you have 40, okay, then you are getting mass number, yes. Okay, so then some energy will be released. Okay, so obviously here you are going to get it as 60, correct? So plus some energy is going to get released. Okay, nice. Next 20, right? So next, yeah. So for 60, what do I have? 60. It is the final product after the two nuclei is merged, right? So for 60, it is in this range. So 8 into 60. I have to look for the reactants first, right? Okay, so 60 into 8. Okay, then 20 and 40, right? So 20 and 40, I'll take it as 4 only. Okay, now I have 20 into 4, okay, then minus, right? So minus 40 into 4. So this is the energy released. Okay, so this is the energy released, right? Okay, now so obviously I'm going to write 8 into 6, right? 48. Then this is 80. Then 160. Okay, 80 and 160, right? Now this is going to be 400 minus 160. Okay, 400 minus 160. I think, yeah, just a second. This is right, this is right. Okay, fine. Now finally I'm going to get it as 240. 240. I think there was some mistake in the options. 20 and 40, what did I take? 20 and 40, I have taken it as 4. Then 60, I have taken it as 8 only, right? Its terms are, yeah, so, yeah, fine. Okay, so 240, right? So 400 minus 160, right? So this is right. So 240 mega electron volts. Okay, so B doesn't seem to be right. Okay, next let us go to option C, right? If it says two nuclei of mass number 20 and 70, 20 and 50 combine, right, and energy of 100 mega electron volt is released. Okay, so let us look at option C now. All right, so what is that? 20 and 50, right? So 20 you have, then 50 you have, correct? Now these two are combining. You are going to get some this nucleus and this energy. So obviously now for 70, what do I choose? Now for 70, again it is 8. Okay, right. Now for 70 into 8, okay, then minus 20 into, now for 20, yeah, I think 20 I should have taken 2 or something, even in option B. Yeah, 20, let me take 2 and check. Yeah, 20 into 2, it is going to be 40. Yeah, now it is right. Okay. So let me take 40 here. Okay. So this is going to be 200. Yeah, 200. Then this is going to be fine. So this is going to be 280 mega electron volts. Yeah, 280 mega electron volts. Yeah, I think this is right. Option B is also right. Okay. Then for 20, let me take 2 only. Yeah. So let me take 2. That will be good. Fine. Okay. So 20 is 2. Okay, now coming back to this option C, now I have 70, then 20 into 2, all right, then minus 50. Now 50 clearly lies in this range. So 50, then I have 8, right? So 50, I have 8. Okay, now this is 560, then you have 40. Now again you have 400, okay, 400, right? Now here you are going to get 560 minus 440, okay, 560 minus 440, it is going to be 120, yeah, so it is going to be 120, clearly 120 mega electron volts, right, but here they have given 100, this doesn't seem to match, okay, fine. Now next, finally, let us look at this one. If a nucleus of mass number 60 splits into 2 parts of mass number 20 and 40, an energy of 320 mega electron volts is released. Now I want you to focus on these two, option B and option D. You can find some similarity. What is that here? So here it is combining, here it is splitting, but if you calculate using the same graph, you are supposed to get it as 280 only, right? You are supposed to get it as 280 only, correct? So therefore, D, right? So D is not right, okay, because so if it is released here, here it should, obviously otherwise you should have got some negative sign there, correct? So it should have been, if this was minus 280 or something, this would have been right, but here you have 320 something, okay, if you had minus 280, take it, it's right, okay, then the correct options, right? So D is also not right, so A and B are right, okay, so A and B are right, okay, so the correct options are A and B, we can say, okay, nice, fine. So next let us go to this. An ideal diatomic gas undergoes a process such that P is proportional to V, okay. At the end of the process, RMS speed of the gas molecules is found double, okay, is found to be double of its initial value. Initially, gas is at pressure P1 and have volume V1, okay. So choose the correct option they have given, okay, nice. So let us see here, now they have given P is proportional to V, okay. Now what can I write from this? So P V power minus 1 is equal to constant, I can say, okay, PV minus 1, yeah, so PV power minus 1 is equal to constant, I can say, right. Now if I talk about the specific heat for the process, right, molar specific heat for the process, that I can write it as, correct. So R, right, so R divided by gamma minus 1, correct. So plus R divided by 1 minus x, okay, R divided by 1 minus x I can write, correct. Now here x is actually what? So x is actually, that is, this is for PV power x is equal to constant, right. That is the general form, fine. Now I have C is equal to CV, right. So CV plus R, that's all, okay. Now I know that this is actually 5R, that is 5 by 2 R CV for diatomic gas, right. So they have given ideal diatomic gas. So this is going to be 3R, okay. So 5 by 2 plus oh sorry, this is minus 1, right. Okay, so minus of minus 1, this is going to be R divided by 2. Yeah, so R divided by 2. So here I have 5 by 2 plus R by 2, correct. So this will be 3R, correct. So this I am going to get it as 3R, right. So do we have an option here? Yes. So B for the process, right, it is obviously 3R, we have it, okay. Next they are talking about heat, right, heat added or heat added to the gas, heat added to the gas, okay. Now we will try to calculate this, okay, nice. Next, yes, so delta Q, so heat absorbed, right, so that I will write it as NC delta T, okay, number of moles here, then N C I have, okay. Now delta T, let me take it as final minus the initial temperature. Tf is the final temperature and Ti is the initial temperature. Now what did they give? Here they didn't give you anything about the temperature, but they gave the information on the RMS speed, right? Now what do you write for RMS speed? Vrms, correct? It is equal to square root of 3 kBt divided by m. Okay. Now as you can clearly see, if RMS value doubles, right? If Vrms doubles, correct, then obviously the temperature will increase 4 times. Okay, it will increase 4 times, right? So obviously I can say Tf, right? Yeah, so Tf is equal to, or I can say 4 times the initial temperature, correct? So Tf is equal to 4 times the initial temperature, correct? So therefore delta Q I can write it as Nc. Now I have 4 Ti minus Ti. Now I have 3 Ti. Okay, so 3 Ti. Now what can I write for C? So C I'll write it as 3R. Okay, so C I already have it here, right? So for this process it is 3R. Now I have 3 Ti. So this is going to be 9 NRTI, right? So 9 NRTI, right? Okay, so finally, from your ideal gas equation, I can finally write it as, they have given the initial pressure and volume as P1 and V1, right? So finally, you can write this NRTI as P1, V1, that is all. Finally, the answer is going to be 9 P1, V1. So the correct options are B and C. Okay, the correct options are B and C. Okay, very nice. So let us go to the next one. So this is interesting question. Okay, a solid insulating sphere of radius A has a uniform charge density R. Remember this, insulating sphere of radius A, that is the sphere which you have it in the middle. All right, fine. It has some charge Q concentric with the sphere, an uncharged conducting shell whose inner and outer radii are B and C. Okay, then these are the options given. Let us try to understand here. Okay, now what have they given? Now for R, that is the values, that is the distance, these references are from the center of the spheres only, that is the shell and the spherical shell and the sphere. Okay, now for between B and C, they are saying E is equal to 0. Okay, between B and C, do you think E is equal to 0? Let us try to understand that. Now we have this insulating sphere, right? Its radius is A. Now charge Q is distributed uniformly. Okay, yes. They have given, okay, total charge Q. All right. So let me take it as positive, no problem. So this is the charge Q which has been distributed uniformly. All right. So next you have this is a surface. Okay. Uniform charge density. Okay, never mind. So the charge is present inside also and the distribution is uniform. You can say volume charge density is uniform, no problem. All right, that is for this insulating shell. Okay, now you have this shell here, so whose inner radius is B and outer radius is C. Inner radius is B and outer radius is C, right? Now because of this, see, you have this charge and this is the shell. The conducting shell is basically neutral. Okay, now due to that you will start getting electric field like this. That is a possibility, right? Electric field is due to this charge. Now this electric field induces charges. Now remember, the shell is conducting. Okay, the shell is conducting. This is the only thing which is, this is insulating sphere, but this is conducting. Okay, this is conducting. So obviously minus Q, negative charge Q will be induced on the inner surface and plus Q will be induced on the outer surface, and again electric field will continue from here, but inside, right, in this region, okay, in this shaded region, this electric field will be 0. You know the fact, right? Inside any conducting substance, electric field will be 0. Okay, fine. So which are the options? Let us try to see here. For B, right, R between B and C. Okay, so they have given, okay, B and C means the shaded region, electric field is 0. Like I said, here between B and C it is 0. True. Okay, next for R between A and B, correct? Now for R between A and B, that is this region, electric field is given by Q divided by 4 pi epsilon naught R square. This is right, correct? Now you know, since we are talking about uniform charge distribution, now this complete charge Q, correct? This complete charge Q, it appears to be, right, all this charge Q, it appears to be concentrated at the center. Okay, now if you take any region, any point between A and B, right? Any point between A and B, right? Any point here, right? So obviously the distance, right? It is going to be taken obviously from the center only, right? So R is measured from the center of this concentric center, that is center for both the spheres, right? At least in this case we are considering the center of the insulating sphere, right? So obviously it is going to be E is equal to 1 by 4 pi epsilon naught Q divided by R square. So this is also right, okay? B is also right. Next, the induced charge on the inner surface of the shell is minus Q divided by epsilon R. No, epsilon R won't come. Why? Because we are talking about a conducting shell, right? So obviously the induced charge on the outer surface of the shell is plus Q. This is also right. See, outer surface of the shell, this is the shell, right? It is plus Q. So C is not right, A is right, B is right, and D is right, okay? So A, B and D, these are the correct options, okay? Nice. So let us go to the next question. Fine. So the conductor A, B, C, D, E has the shape shown in the figure. It lies in the YZ plane, okay? So YZ plane is this, okay, with A and E on the axis, okay? So A and E, these two ends are on the axis, okay? Fine. Now when it moves with the velocity v in a magnetic field B, and EMF E is induced between A and E, okay? Between A and E, and EMF is induced, right? Okay, now these are the options. E is equal to 0 if V is in the Y direction and B is in the X direction. Next, E is equal to 2BAV if V is in the Y direction and B is in the X direction. Okay. Next, E is equal to B lambda V if V is in the Z direction and B is in the X direction. Finally, E is equal to B lambda V. Now, if V is in the X direction and B is in the Z direction. Now, let us see option by option. Okay. First option, it says if V is in the Y direction and B is in the X direction, okay. So, X axis is towards you, right. So, YZ plane is this board, imagine like that, okay, right. Now, B is in the X direction. This is only for option 1 I am saying. So, B it is towards you, okay. Then E is equal to 0 if V is in the Y direction, okay. Now, whenever we talk about EMF induced in a, that is motional EMF, right. So, we will always consider, imagine this EMF induced in the conductor, right, is as if the conductor, that is you just need to consider the length, right, the effective length between the end points, right. Now, the effective length between the end points is nothing but this AE only, which is given as lambda, okay. Now, this is as if a rod of length lambda, okay, a metallic rod of length lambda is moving with velocity v this way, okay. See, v is in y direction, right. Now, we all know that if these a rod, right, a rod or a wire, straight wire, if it is not cutting the magnetic field lines, see, magnetic field lines are like this, okay, it has to cut the magnetic field lines like this, okay, if it is moving this way, right, if it is moving, right, so if it is moving parallel to its length, we'll say, okay, there won't be any EMF induced, right. So, because the velocity is in the y direction for option A, right, okay, so there won't be any EMF induced, okay. So, this is right, E is equal to 0 if V is in the y direction and B is in the x direction, this is right, okay. Next, if V is in the y direction and B is in the x direction, let us see that, okay. Now, B is still in the x direction, it is towards you, okay. Now, if V is in the y direction, that I have to see, okay. So, V is in the y direction, again you know that V if it is in the y direction, okay. So, what is the difference between option A and B? They have given some value 0 here and you have some finite value here. If option A is right, option B is not right, okay. So, everything else is same. Here you have the correct option as correct value as 0. So, obviously 2BAV it is not right, correct? Okay, so B is not right. Now, let us come to C. Okay, now V is in Z direction, right, there is something change here. So, the loop, right, sorry, it is not a loop, sorry. So, it is a bent conductor, it is going like this, okay, in Z direction and B is in the X direction. So, B is still towards you, okay. Now, it is as if the rod is moving like this. So, when it is moving like this, its velocity is perpendicular to the length, right. It will be cutting some magnetic field lines, okay. So, like I said, just take the effective length. Now, you know, we will use this EMF, motional EMF is equal to BLV, that is all, okay. So, B you have length they have taken as lambda, then V, okay. So, you have B lambda V, this is right, okay. C is right. Now, next they are saying E is equal to B lambda V if V is in X direction and B is in the Z direction, okay. Now, B you have to take it like this, okay. B is like this now, B is in the Z direction they are saying, correct, and V is in the x direction, okay. B is like this, okay, then V, right, velocity is in the x direction. Now imagine the rod is coming towards you like this, okay. Obviously still it is cutting the magnetic field lines, right, and velocity is perpendicular to the rod, okay. So obviously here also you are going to get the same answer, correct, because V and B are perpendicular, correct. So obviously A, C and D, all the three are correct. B is not right, okay. So this is the answer, fine. So let us go to the next question, fine. So in a nuclear reactor, an element X decays to a radioactive element Y at a constant rate 10 power 15 atoms per second. Each decay releases 100 mega electron volt energy, okay. Half-life of Y equals T and decays to a stable product Z, okay. Each decay of Y releases 50 mega electron volts, right. All energy released inside the reactor is used to produce electricity at an efficiency of 20%. Calculate the electric power generated in the reaction in steady state, okay. What do you mean by steady state? Here you need to consider the, yes, so first it will go from X to Y, then Y to Z also, right, correct. So you need to consider the energy released from X to Y, okay, then Y to Z also. But if you look at the energy release when the decay is taking place from X to Y, it is 100 mega electron volt, right. Yeah, fine. So each decay releases 100 mega electron volt, right. Okay, then here again from Y to Z, it releases 50 mega electron volt. Now all you have to do is in steady state, right, you will be getting 100 mega electron volts of energy per decay, correct, per decay from X to Y transition. Now from Y to Z decay, you can say you are going to get a steady energy of 50 mega electron volts per decay, correct, that is all, okay. Now in the same case they have given 10 power 15, okay. Now X to Y, okay, if I talk about, this is a numerical based question, right, numerical based question. Okay, they have given kilowatt, yeah, fine. So X to Y, so let us see, now 10 power 15 atoms are there, okay. Now per decay, what I have to do, I need to multiply it by, this is the number of decay. Now for per decay you are getting 100 mega electron volts, okay, 100 mega electron volts, right. Now they are asking you, the question is power, okay. Finally the answer must be kept in joule per se, watts you can say, right, okay. Now Y to Z, how many? Same, 10 power 15 only. Again, it forms a stable product Z they have given, okay. So consider that. Now you have 50 mega electron volt, okay, 50 mega electron volt, right. Now finally, how much do I have? I have 100, 150, correct. So 10 power 15, if I take common, if I am going to add them, right. So 150 into 10 power 15 mega electron volts, okay, fine. So next 150 into 10 power 15, okay, into, yeah, now let us talk about the electrical power you need to find out. Now they have given the efficiency as just 20%, okay. So this is the energy released. Now in that 20%, so let me consider 20%, fine, okay. Now this is in mega electron volts, okay. Now let me simplify this. Now I am going to get 5 times, right, then 30 times, okay. So 30 into 10 power 15. Now they have given 1 mega electron volt as 1.6 into 10 power minus 13 joules, okay, 10 power minus 13 joules. So 10 power minus 13, so 16 into 3, 48, correct. Yeah, so 16 into 30 is 48. Now I am going to get into 10 power 2, right. So this is 4,800 watts, but I think you need to highlight, right, you need to mark in kilowatts, right. So obviously this is going to be 4.8 kilowatts, this much amount of electrical power. So this is only the electrical power. Why? Because 20% of the energy released will be converted to electrical power, electrical energy you can say. Okay, nice. So this is the answer, all right. So let us look at the next question, right. So this is interesting. A long solenoid of cross-sectional radius A is equal to 10 centimeter has a thin insulated wire, right, ring tightly put on its winding. Okay, one half of the ring has the resistance eta times that of the other half. Okay, the magnetic induction produced by the solenoid varies with time as B is equal to Bt. So this is the magnetic induction that is varying with the solenoid, right? Now here B is actually 4 Tesla per second. Okay, 4 Tesla per second, constant. Okay, now the magnitude value of electric field strength in the ring is found to be 10 into 10 power minus 2 Newton per Coulomb. Find the value of eta. So this involves a large amount of calculations. Okay, let us try to see that. All right, fine. Now, yes, now they have given the value of the electric field strength in the ring, right? So this thin insulated wire, okay, ring tightly put on its winding. Okay, now what do we have? You have a solenoid, right? So due to that solenoid, you have this magnetic field B, which is given as Bt. Okay, now the solenoid is like this, let us say. Okay, then let us try to sketch a rough diagram here. It will be easy for us. Next, I have this ring. Okay, I have this ring, very thin ring. Okay, now what are its characteristics they have given? They have given, right? So this is the front view. Let us say half of the ring. This is the center O. Now here the radius is R if you consider. Now the other half, right, it is having eta times, okay, eta R. That is what they have given. Okay, nice. And the cross sectional radius, obviously if they give thin ring, right, so yes, thin insulated wire, its radius is also going to be 10 centimeter only. Okay, its radius is going to be 10 centimeters, right? Now let us substitute the values at the end. Now let us try to get solve the problem here, right? Now you need to get the electric field strength. Okay, now what do you observe here? So this B, right, magnetic field inside a solenoid, and that magnetic field is passing through this ring also. You can say flux. Flux linkage is not zero with respect to this ring which is wound on the solenoid, right? Now this is actually 4T. Correct. Now, as time passes, what do you notice? Magnetic field B, do you think it is constant? No, it is changing, right? So, obviously, the flux linking with this ring also changes. So, if the flux linking with this ring is changing, EMF is induced in that, correct? Electromotive force is induced in that, right? Now, obviously, we are going to take that approach here. Okay, nice. So, next, what do we know? EMF induced, it is going to be d phi divided by dt. Okay, d phi divided by dt. Now, what is the flux which is linking here? So, flux is nothing but B, B and area vector both are in the B dot A, right? In this case, you will get BA cos 0. So, this is going to be B into pi A square. Okay, B into pi A square, right? Now, let me put it here. So, d by dt of B into pi A square. Okay, next, let me substitute for B. B is nothing but small bt, okay, small bt. Small b is constant, okay. So, d by dt of, now you have b t pi a square, okay. Now, finally, EMF, I am going to get it as pi a square b, okay. We will keep it for future calculations, further calculations, we will be using this. Okay, nice. Now, let us come back to the ring here. Now, this was the ring. Right, fine. Now, how do we give, electric field, right? Electric field will be present inside the ring throughout its length, correct? Now, if I take these 2 points, correct? So, here the radiuses are for the upper semicircle. Now, for the lower semicircle, it is actually eta r, right? Now, next, what I can do is, so usually how do we write? EMF, right? So, EMF is equal to I into R. Correct, EMF is equal to I into R will write. Okay, so next what I can do is I need to consider the EMF induced, correct, EMF induced and the right. So here for the complete loop it is E, correct. Now for the complete loop it is actually E, right. Now for this one, so they have given E, that is resistance, right. So resistance, it is going to be different. Okay, so once again let me take my notes. All right, so if I take, yes, so here I'll use the concept that the potential difference between these two ends is going to be the same. Okay. Now here I need to consider the potential difference due to the fact that current is flowing through the resistor as well as the EMF also, that is the potential difference due to the electric field, right. Now what do we know about electric field? We usually will say V is equal to ED, correct, or E is equal to V by D if we talk about uniform electric field. Now I told you that the electric field inside, right, it will be uniform. Okay. Now let me consider the upper loop here, right. So if you consider the upper loop, what I have to do is, right, so E, fine, so E, this is the EMF, okay. So this is a general formula, don't consider this now, okay. So E by 2, for half of the loop it is E by 2, correct? Yeah, I'm right, I'm correct, okay, nice. So next, if I talk about the electric field, right. So electric field, let me consider this in one direction now, okay. So let me take it like this. Now if you consider the upper loop, right, now I'll be using this expression here, E into D, okay. So E is the electric field, okay, electric field. Then the distance, what can I write here? The distance they have given A, right. So A is the radius, okay. So 2 pi A is the circumference. Now obviously here it is going to be pi A, correct, half of the circumference, okay. So that is going to be, you can say, right, so this is the potential difference. Now I can say here the radius, right, sorry, the resistance is capital R. Now I am going to write it as I into R, okay. Now I am going to write it as I into R, right. Now if you consider this loop, right, now I have E by 2, okay. Now I am coming in this direction, I am going to add it, right. So E pi A, okay, then pi you can write it in the beginning, no problem. Now here the resistance here is eta R, right. So I into eta R, I'll write, okay, I into eta R. Now what I have to do is, finally I have to get eta. For that I have to simplify whatever is possible, correct. So next I'll take, I'll add these two, just a second, yeah. So I'm going to add these two equations, right. If I add these two equations, these two terms will get cancelled. Now I have E is equal to, right, now I have IR, take it common, okay, IR I have, yeah, so IR, then I can write eta plus 1, okay, I can write it as eta plus 1, fine. So next what else can we find? All right, so let me get this E now, okay. So after you solve for E, right, yeah, this is right, fine. So E I'm going to get it as, I'm going to write it directly here because I don't have much time. All right, so this is going to be eta minus 1, just have to put the value of E here, okay. See, these two are simultaneous equations, right. So just put the value of I there, substitute the value of E in these two equations. The electric field you are going to get it as eta minus 1, okay, eta minus 1 times R I divided by 2 pi A. So this is what you are going to get, okay. Then finally you can substitute for I from here, okay. See here I can write E divided by, okay, I can write it as eta minus 1 into R divided by 2 pi A, okay. Now for I will write it as E divided by R into eta plus 1, that's all, okay, nice. So R and R, it is getting cancelled as you can notice, okay, nice. So finally, yes, I think they have given the expression, right. Yeah, now I have to substitute for this EMF here, see, pi A square B, I can put it here. So finally E, I am going to get it as 1, all right. So eta divided by 2 EMF, right, EMF is pi A square, I think, yeah, pi A square B, okay, whole thing divided by 2 pi A, nice. Now finally next I have eta minus 1 divided by eta plus 1, okay. So this is right, eta minus 1 divided by eta plus 1, okay, nice. So pi you can cancel, 1 A you can cancel, so finally you are going to get half of AB into eta minus 1 divided by eta plus 1, okay. Now finally E, right, what did they give? 10 into 10 power minus 2, okay, 10 into 10 power minus 2, that is all. See, we have the expression in electric field, then what is A? A is the radius, B is that constant 4 Tesla per second, so eta is the only unknown. So 10 into 10 power minus 2, okay, so that will be half into, now A was 10 centimeter, So 0.1 meters I'll take. Okay. Next B is going to be 4. Nice. Okay. So then eta minus 1 divided by eta plus 1. After you solve, right, after you solve, the value of eta you will find it as 3. Okay. So the correct answer is actually 3. Fine. So coming to this part, right, we need to consider the effective potential difference. Now you have potential difference. So this is the due to induced EMF, correct, and you also have this electric field also, right, potential due to the fact that electric field is also present, right. Okay, that is all, right. So thank you. So next chemistry chemistry sir, Kishore sir is going to continue with chemistry. All right. So thank you. Study well.
So, welcome to Extramarks, and today we are going to discuss the JEE paper which was held, and we are going to see the chemistry part. So, hope you guys had a well elaborate discussion of the physics, and now we are into the chemistry part. Let's see how the chemistry part, paper was. And when we come to the chemistry part of the advanced examination, it is all based on the concepts. So, not only a single concept. Like suppose if I talk about a question in electrochemistry, let's say Nernst equation. So, you get a question based on not only the formula based on the Nernst equation, you also get question which is related to the thermodynamics part. So, in advanced paper you always see the chemistry questions which are having multi concepts linked together, not multi concepts, I would say the multi chapters. So, one chapter connected with the other chapter. So, I have few questions which were asked by my students. So, let's see a few questions to clarify their doubts. Okay. So, there are few questions which I have collected which have got a lot of concept in it and which has got linked with other chapters. Okay. So, the first question which I am going to discuss here is from the chapter, it is from the chapter called as, so can you identify from which chapter it would be? Yeah, they are talking about the lead storage battery, right? So, it is from the chapter called as electrochemistry. And what do we think is this particular topic which comes at the end of this chapter talking about the batteries, the commercial, the primary and the secondary batteries, and what do we think is, this topic is not so important for us and we just keep it aside. But you can see that there is a question which has been created on the particular topic which we are not expecting. So, always expect a question from an unexpected topic. Okay. So, basically in this chapter what we will expect is you can also expect questions from Kohlrasch law, which is very, very important. Very rarely they also ask from electrolytic conductivity. So, electrolytic conductivity you might get a question which is of easier level from Kohlrasch law and its application, which is again of a multi-concept thing. And then you can also get questions from Nernst equation related to the Gibbs free energy. So, there are very good topics from this chapter, and this is not the topic which could be kept aside. So battery is also a very important topic where you get questions, sometimes very direct questions like what is the anode, what is the electrolyte, what is the cathode. So simple questions related to the primary and secondary batteries. So you can get a question from this particular concept also, the batteries. Okay. So let's see what kind of question did they ask us. So if you look at the question here, right. So the question is that they're asking us the equivalent weight of H2SO4 during the functioning of lead storage battery. Okay, so that's the question they're asking us. It means, so here they are trying to check whether we know what is the lead storage battery, whether we know the redox reaction which is happening in the lead storage battery. So what is the reaction at anode and what is the reaction at cathode? And moreover, this lead storage battery is a rechargeable battery where you have a reaction which will go forward, so it can be reversed. So there will be a discharging and charging reaction, right? So let's see how can we do this. So for this, first you have to have an idea about the chemical reaction which is responsible for this particular lead storage battery and its working. So if when we are talking about the discharging and discharging, this equation is very, very important. So this is an equation where the electrolyte, so you have the cathode, okay, you have a cathode, you have an anode, okay, so this is, okay. So this is one of the components. So you know that in lead storage battery you have the grids made up of lead and lead oxide dipped in electrolytic solution of H2SO4. So the electrolyte is H2SO4 here. So these are the few questions which have been asked a lot of times. What is anode, what is cathode, and what is the electrolyte? And if you see over here, the electrolyte has been consumed. So during the discharging, so when it is getting discharged, when the batteries are getting discharged, it is the H2SO4 which is getting consumed by both the anode and cathode part. So how do we identify the anode and cathode part now? Very small trick which I will give you is just look at the oxidation number. I am sure you know how to write down the oxidation numbers. If you look at the oxidation number of lead over here, it is +4, right? And what is the oxidation number of lead over here? It is 0 in its metallic form. And what is the lead oxidation number of lead over here? It is +2, right? So if you see over here, this lead oxide, so this lead is getting reduced, right? You can see that there is a reduction happening here. So this is the reduction part, right? And you will see the oxidation part over here. So this is the oxidation part. So by this you can easily identify which compartment is going what. So this is undergoing oxidation. So this is the anode compartment, right? So this is the anode compartment and this is a cathode compartment. And both of them are consuming the electrolyte H2SO4, forming a crystal. So you will find these crystals. So this is the product which is obtained while it is getting discharged. So lead sulfate is the product which is obtained during the discharge, and you get a white crystalline structure, white crystalline powder below the anode and below the cathode. So this was the discharging. And what is the recharging, tell me? So if you want to recharge this battery again, it is the lead sulfate again coming back into the electrolytic parts, that is H2SO4. So that is a recharging part. So let's look at the question, what they are asking us. So if you look at the question, they are asking us the equivalent weight of H2SO4. So see, they have linked this concept of the lead storage battery with the concept of equivalent concept, and this equivalent concept is the one which has been asked a lot of times in questions related to equivalents are very oftenly seen in JEE Advanced exam. So you should have a very clear idea about the equivalent concept that is there in redox chapter. Some of you also learn in the chapter called as the first chapter, that is some basic concepts. In mole concept and stoichiometry you also learn about this. So this is a very important concept which is oftenly used in a lot of numericals of JEE Advanced exam. Okay, so let's find out the equivalent weight of H2SO4. So to answer this, what do we need? So to answer this, the first thing that I need is we need to apply. So we can apply a law of equivalence. So according to law of equivalence, we know that equivalent weight of any of the components can be equated to the other component, right? So according to law of equivalence, now can I write down, let me equate two things, okay? So, and one more important thing, if you observe here, the number of moles of electrons, how many moles of electrons are getting transferred in this particular reaction? You can see there is a reduction by 2 and there is an oxidation by 2, right? So there is 2 moles of electrons. So there is 2 moles of electrons, 2 moles of electrons being transferred, okay, or there is a movement of 2 moles of electrons. So because of which there is a generation of electricity, right, for every 1 mole. So for every 1 mole of the reactants taken and 2 moles of H2SO4 taken, we get 2 moles of electrons that are getting circulated in the circuit. So now the question is what, tell me, they are asking us the equivalent weight of H2SO4. So whenever you get a question on equivalent weight, let's apply the law of equivalence. So according to law of equivalence, let me equate any one of them, okay. So I just want to find what, tell me, I want to find out the equivalent weight of H2SO4. So I am going to equate, you will come across the law of equivalence in the chapter called as redox, where you learn about the titrations, okay. Right. So here I am going to write down equivalents, okay, equivalents of, let's say, the lead oxide, okay, or the lead is equal to the equivalents of H2SO4 consumed. Equivalents of H2SO4 consumed. You can take anything. You can take lead oxide also, no problem, anything. So with respect to anything, so equivalence of lead oxide is equal to equivalence of lead is equal to equivalence of H2SO4, that is reacting in a particular reaction. So according to this law of equivalence, it's called as a law of equivalence. So according to this law of equivalence, I have applied equivalence of PbO2 reacting in this particular reaction is equal to equivalence of H2SO4 participating in this chemical reaction. Now we should know how do we express this equivalence, okay. So let me give few ways in which you can express equivalence. So how can you express the equivalence? So equivalence, if you want to express the equivalence, there are different ways in which you can express the equivalence. So equivalence can be expressed, the best method to express equivalence is normality into volume. So normality into volume will give you the equivalence, the gram equivalence. You get the gram equivalence by multiplying the concentration term normality with volume. Okay. You also get this by multiplying n factor into volume into molarity. N factor into molarity into volume. So this is another way by using, this is by using normality, but this is by using molarity. Okay. There is one more way in which the equivalence can be expressed, the gram equivalence can be expressed, it is the n factor into number of moles. N factor into number of moles, or you can also express this in terms of weight. How can you express this? It is the weight of the substance by its equivalent weight. So this is your equivalence, gram equivalence. So you can express gram equivalence in different ways. It could be in terms of weight, it could be in terms of number of moles, it could be in terms of molarity, or it could be in terms of normality. So these are the different ways in which you can express the gram equivalence. Okay. So now I am going to use one of these formulas to get my answer. Okay. The question is what about, tell me? It is about the equivalent weight of H2SO4. Right. So to find the equivalent weight of H2SO4, see what is the formula for equivalent weight of H2SO4? So the equivalent weight of H2SO4 is equal to its molecular weight by n factor. Right. So if I want to find out the equivalent weight of H2SO4, it is this formula, molecular weight by n factor. So to find out what is the molecular weight, do you know? The molecular weight of H2SO4, yes, it is hydrogens 2 plus 32 plus 64, it is 98 grams. So this is the molecular weight of H2SO4, the molar mass. So molar mass by its n factor. Now how do I find what is the n factor of this particular acid in this particular reaction? So let's see how to find out the n factor. So because H2SO4, we know that, see, for an acid we talk about the n factor in terms of the number of H plus ions, ionizable H plus ions it is giving in a particular reaction. Right. So in this reaction, whether it is giving both the H plus ions, both the H plus ions are involved in the reaction, or only one H plus ion is involved. So it could be 1 or it could be 2. So to find the n factor, we are going to use this one. Okay. So what I am going to do is, according to this equation, if you look at this equation, it is 1 mole of this reacting with 1 mole of this reacting with 2 moles of this. So according to the stoichiometry, this is the ratio in which they are reacting. Okay. So what formula I am going to use is the n factor. Okay, the n factor of this PbO2 into the number of moles is equal to the n factor of H2SO4 into the number of moles of H2SO4. Okay, so this is for the H2SO4 part and this is for the PbO2 part. Okay. Now, if you see, according to the stoichiometry, every 1 mole of PbO2 will require 2 moles of H2SO4. Right. So with every 1 mole of PbO2 in a chemical equation, it requires 2 moles of H2SO4. And in this reaction, how do you find out the n factor of PbO2? It is the number of electrons that is getting exchanged by this molecule. And you know there is 2 moles of electrons which are exchanged by the molecule. So PbO2 is able to give 2 moles of electrons in this particular reaction at cathode. Okay. So what is this happening here? So n factor. So what will be the n factor of PbO2 here? It will be 2. Okay. So it is the oxidizing agent. It is the number of electrons involved in the at the cathode compartment and the anode compartment. So, it is the number of electrons. So, the 2 moles of electrons. So, there are 2 moles of electrons involved. So, this is the 2 moles of electrons involved in this particular reaction. So, 2 into 1 is equal to, we need to find out the N factor of this acid, right. So, what will be the N factor of this acid? So, 2 and 2 gets cancelled. So, the N factor. So, the N factor of H2SO4 in this particular reaction is how much? It is 1. So, to find out the equivalent weight, I need to know the N factor, and I got my N factor from this formula. And where did I get this formula from? From the different ways in which we can express the gram equivalents, N into N factor. Okay. So, you can use various other ways. This is an easier method to do it. Okay. So, N into N factor, number of moles of PbO2 involved in this reaction, its N factor is equal to N factor of H2SO4 into number of moles of H2SO4 involved in this. So, I got this 1 and 2 moles from the stoichiometrical equation which I have written. For every 1 mole of PbO2, there is 2 moles of H2SO4 which is involved, and there is 2 moles of electrons which are getting exchanged. So, the N factor of PbO2 is 2, 2 into 1 is equal to N factor of H2SO4 into 2. So, the N factor comes out as 1, and once I substitute this here, so N factor is 1. So, it is 98 divided by 1, nothing but how much it is? It is 98. So, the equivalent weight is 98. So, that was a question from electrochemistry part, which is actually related to the discharging and the recharging of the battery, that is the rechargeable battery. But the question has been linked with the redox chapter, where we apply this gram equivalent concept. So, I hope, so he was trying to check, the paper was trying to check whether we know the concept of the secondary batteries, and do we know the concept of law of equivalence to calculate the N factor, right. So, this is the easiest method that you can apply to get an answer. So, this is a question, the first one from electrochemistry, apart from the other topics from where you can expect the questions, right. So, let us move on to the next one. Okay, the next question is an organic kind of question, and if you can see, they are asking us which of the following is the most basic compound. They are asking us the most basic compound. So, this kind of questions are also very common in this organic chemistry, and you can expect definitely a question on either the acidic strength. So, this acidic strength could be also asked in terms of Ka, decreasing value of Ka or increasing value of pKa. So, based on acidic strengths, you can get a question on acidic strengths. You can also get a question on basic strengths. Okay. So, these are definitely you will see this question in your exam, either in the paper 1 or in the paper 2. So, this is again a question which is expected, that is from a basic nature or from the acidic nature. And please do not forget about the ortho effect that could be applied in the case of acidic nature as well as in the case of basic nature. So, that is very important, right. So, let us see what is this question about. They are asking us about the most basic compound, and they gave us the 4 different compounds, and these are the compounds from the chapter called as amines. So, let us see how can we answer this. So, the first impression which I get is that you have option number B here. Okay. So, I have options here. So, this is option number A, B, C and D. So, the first impression which I get is you can see that there is lone pair of electrons. When we talk about the basic nature, it is the ability, the Lewis basicity is the ability to donate the lone pair of electrons, right. So, let us see which is able to donate the lone pair of electrons very easily, okay. So, and form a conjugate acid. So, when we talk about the basic nature, the compound which is more basic in nature will try to convert into a conjugate acid which is weaker. A strong base will convert into a weaker conjugate acid, or you can say a stable or a stable conjugate acid, right. So, we have to look for those conjugate acids which are more stable. So, let us go for one by one discussion. So, if I look at the lone pair of electrons which are available in over the nitrogen, if I look at the option number B, so because option number B, if you see, these lone pair of electrons are not available for donation. Why do you think? In alanine, we have learned that this lone pair of electrons are involved in resonance, right. So, they are involved in resonance, and hence these lone pair of electrons are not available for donation. So, I would say B is the least one among all the 4. Okay. Now, when I look at all the other 3 options, if you see, this is a primary amine, it is a primary amine, right, and this is a secondary amine, and this is a tertiary amine. And one more important thing that you should keep in your mind is whether if you go to amines chapter, there are 2 types of basic strengths that are written: in the gaseous phase where you have discrete molecules, and in the solution phase. So, in the gaseous phase, it is quite easier to conclude at the basic nature, because we just have to look at the inductive effects. Okay, we have to look at the inductive effects, or we have to just look at the electronegative atom to which it is attached. So electronegativity we have to look at. So these two concepts are enough. We are looking at the inductive effect, the group's inductive effect, and the electronegativity of that particular atom. Okay, but when it comes to the solution part, in aqueous solution, you have those questions in your NCERT book too. So when it comes to the aqueous solutions, there is one more important factor, that is the hydration or the solvation factor, which comes into the picture, and there is something called a steric factor also. So these all factors are very, very important when you decide the basic nature. So what is that? Inductive effect. You also have to look at the electronegative. Inductive effect is again based on the electronegativity. You should also look at the various stability factors also, the steric factors and the hydration. So in the case of the gaseous atoms, so because they have not mentioned this as aqueous solution, so we are going with the assumption that this is for the gaseous discrete molecules. So there I am going to apply very few concepts, that is I am going to look at the hybridization, and also I am going to look at the inductive effect. So let's look at the inductive effect and etc. So if you look at this case, okay, so primary. So usually we see that whenever we come across the discrete molecules and their basicity, it is the tertiary which is the most dominating, then secondary, and the primary. Because of what? Tell me. Because of the plus I groups which are attached to the nitrogen. So this plus I groups increases the basic nature of this amines, right? So tertiary is the highest, then secondary and primary. So based on that, your answer is already ready. So this is your answer, because you have the plus I groups. So you have the plus I groups which are pumping in the electron density over the nitrogen and increasing its basic nature when compared to the other two. So this is secondary and this is primary. Right. So your answer is what? It's very simple. So the question is, I would say it is easier one, could be answered by anyone who is thorough with the NCERT books. So my answer is option number D. My answer is option number D. So this is a very simple question which has been asked, and it's a bicyclic compound of heptane. Okay, you can see 1, 2, 3, 4, 5, 6, 7. Okay, it's a bicyclic compound of heptane. There is a very good question which has been asked on this particular molecule. Okay, if you look at this molecule, it's not free. Okay, the alkyl groups which are attached, all the 3 alkyl groups which is attached to this nitrogen are not free. It's also called as the caged structure. It's also called as a cage structure. So it is called as a cage structure when compared to a triethylamine. Okay, so trialkylamine. So here the question which could be asked maybe for the next time is, they can ask you about the nucleophilicity. Okay, so which is better? Nucleophilicity. So what about the nucleophilicity? It means the ability to participate in SN2 reaction or any kind of substitution reactions. So if you talk about the nucleophilicity, nothing but its ability to donate the lone pair of electrons, right, to a electron deficient atom. So which one do you think? So this electrons, okay, among the previous question, you found that this was the better one, right? This is also a tertiary, this is also a tertiary, right? Both of them are tertiary, and you have the lone pair of electrons available in both the cases, and both the nitrogens are also sp3. So which one do you think is a more better nucleophile? So if you look at this particular compound, there is a concept called as inversion. There is a concept called as inversion. Okay, and you can see these lone pair of electrons are easily available, since it is an alkyl. It's a cage structure. The alkyl chains which are attached to the nitrogen are fixed, so there is no movement of this caged ones. Okay, so this lone pair of electrons are easily available for donation. But if you see these alkyl groups which are there around it, okay, the ethyl groups which are there, they are free. And moreover, it is an sp3 hybridized atom, right? So they are free, and what happens is that these lone pair of electrons, so because of the steric factor of this ethyl group, so because they are free alkyl chains around it, so they make the availability of the lone pair of electrons a bit lesser when compared to this. So yes, they are very good. They are very good at donation, but it is lesser when compared to this, because you have an alkyl chain which are fixed, and here they are free. So they are able to, they have some steric factor which is involved here. So its pK is a bit lesser when compared to, or we can say its basic nature is quite lesser when compared to this. Okay. So there is one more question that you can expect from here is, there is something called as inversion, right? So this is an sp3 carbon, right? So we come across this question also, where so in this question you come across, like, this is an sp3 carbon, sp3 atom, okay. So sp3 atom and having all the groups around it, if R1 is not equal to R2, let us say R1 not equal to R2 not equal to R3, all the groups are different. If R1 not equal to R2 not equal to R3, then all the groups are different and hence this is a chiral molecule. But what we expect, tell me, so being all the groups different around the sp3 carbon, we say that this particular molecule is chiral and it is optically active, it will have enantiomers. But what is being seen is that there is a concept of inversion, okay, it is called as amine inversion, okay, nitrogen inversion, you can say inversion, or it is also called as the umbrella inversion, okay. You can see the umbrella. So, whenever there is a heavier wind, you can see the umbrella gets inverted, right. So, that is what is happening. It is also called as flipping. So, there is always a flipping of this, all the 3 alkyl groups on the one side and lone pair this side, and what happens, it flips. So, there is always a flipping of the lone pair of electrons, so because of which you are expecting this molecule to be a chiral, but you will not get 2 differentiating D and L isomers, okay. You will not be having the 2 differentiable D and L enantiomers. So, this is optically inactive. It is optically inactive because it does not have a differentiable D and L enantiomers because of this inversion which is happening rapidly or flipping of the lone pair of electrons. So, this is one more interesting concept from where you can expect a question. So, this was a very basic question, but it could be asked. So, questions related to nitrogen inversion can also be asked, right. So, that was my answer, that is your heptane, okay. So, which is the most basic among all those things, but and also very good nucleophile too when compared to the other ethylamines, right. The next question is from the electrochemistry part, as I was telling you. So, you will be getting some questions based on the Nernst equation or related to the electrode potentials. Here you have the question on electrode potentials, okay. So, and it is a easier question because they gave us all the values. So, they gave us the SRP values, all these values are SRP values. So, you should be very careful with they can give you a easier concept by just altering the electrode potential values. So, we are used to do questions based on SRP, but they can give you something in terms of SOP. Okay, so you have to be very careful with this. So, this is a question on standard reduction potentials at 298 Kelvin, that is the standard reduction potentials. The half cell reactions are given. So, I have the 4 half cell reactions which are given, and I have my SRP values. These are negative, this is negative, this is 0 obviously, which is our standard electrode, and this is positive, okay. Now, how do I decide what is a stronger reducing agent? So, which is a stronger reducing agent based on the SRP values. So, if you can see, there is a topic called as electrochemical series and its applications. So, this is a question which is from the electrochemical series and its applications, okay. So, how do I find what is a strong reducing agent and what is a strong oxidizing agent, which metal is more reactive, which less reactive metals. We can also find out which metal can be used as an anode, which can be used as a cathode, okay. So, there are a lot of applications of electrochemical series. So, you can answer. So, I will give you a small sequence in which you can learn the based on SRP values, you can arrive at a lot of answers, okay. So, the sequence which I want to give you is, so the SRP values which we talk about, okay. The SRP values which we talk about, the standard reduction potential values, let us say with the magnitude, okay, we are looking at the magnitude with the sign. So, so when we look at the SRP values, if it is less, okay, I am comparing 2 values, okay. So, I have 2 readings of SRP and one of them is lesser and the other one is higher. So, when the SRP is less and when the SRP is more, so I am talking in terms of relatively, because the question is also in terms of relative, comparing the SRP values. So, you will be getting questions on comparison, okay, of the relative SRP values. So, if the SRP value is relatively lesser, what are the conclusions, and if it is more, it means lesser means what, tell me, a negative, more negative, okay. If it is more negative, just go with the mathematical scale. So, lesser values means all to the negative and higher values means to the positive side, right. So, lesser SRP values, whenever you have lesser SRP values, you can conclude that it is a very good reducing agent, okay. It is a very good reducing agent. They can be used as a good reducing agent, and these are what? They can be used as oxidizing agents, Okay, suppose I suppose for example over here I have this negative value and I have a positive value. So when I compare these values, or you can compare anything, like suppose if I compare minus 0.762 and minus 0.74. So this is more negative when compared to this. So the lesser one is a good reducing agent when compared to the other one. Okay, yeah. So that was about reducing agents. Okay, and if you see here, or you can say these are more active metals. These are more reactive metals. Reactive metals, or you can say active metals. Reactive metals. These are more reactive. We have seen the sequence, right? You might have been learning the sequence of reactivity of metals. So the one with a more negative, okay, lesser SRP value is more reactive metal, and this is a less reactive metal. Less reactive metal. It means a metal with lower SRP will replace a metal with higher SRP value. That's a concept which you can apply. So you can learn what's called as the metal displacement reaction. You can apply this concept. Okay. Now, one more thing is that since it is a good reducing agent, it means what? Tell me, it will undergo oxidation very easily, right? It is a good reducing agent means it will undergo oxidation. Reducing agents will reduce others and they will oxidize themselves. They will undergo oxidation very easily, and oxidizing agents will get reduced very easily. And where do you see this process of oxidation in a galvanic cell? It is oxidation happens at anode. So this happens at anode and this happens at cathode, right? So this happens at anode and that happens at cathode. So you can answer one more question. What is that? Which metal can be used? By looking at the SRP values, you can actually decide which will start acting like an anode and which starts acting like an cathode. So this is a sequence. So a good reducing agent, a metal which is more reactive, which can undergo oxidation very easily and give electrons easily, will be used as an anode, and the one which is relatively lesser reactive will undergo as cathode when connected as a electrolytic, when connected as a electrochemical cell. Okay. You can also conclude many other points. So more reactive metals means what? Tell me, they will have less ionization energy. They will have less ionization energy. They can ionize very easily. The metals with lower ionization energies are more reactive, and same goes with this. So less reactive means more ionization energy. Okay. So in this way you can go on connecting a lot of concepts together. So this is one way in connecting all the concepts with the SRP values, lower and higher SRP value. Don't get confused with the minus and plus sign. I have used the word lesser and higher, okay, low and high. So it will be easier for you to look at the answers. If you see here, the strongest reducing agents. The strongest reducing agent means nothing but they are looking for the most, you have to look for that particular electrode reaction where it is the SRP value with most negative. If you see, this is a positive value, okay, and this is minus, but is 0.74, and this is minus with 0.76. So this is, I would say, the most least SRP value, and the most least SRP value is a good reducing agent which could be used as an anode where the oxidation will happen. So I would say my answer is zinc. Okay, so zinc is something which will can be used as an anode, and it gives the oxidation process happening at anode. So which is according to the SRP value. So this can be used, and this you will find it in your NCERT. This is nothing new. It is from your NCERT book from the topic called as electrochemical series and its applications, right? Okay, so that is a question from again electrochemistry. So now we have one more question which is from organic chemistry, that is Cannizzaro reaction. So the mostly asked, so if I say the most important chapter among all the organic chapters, I would say aldehydes, ketones and carboxylic acid is the most important chapter from where you get multiple questions, not one question, you get multiple questions. And the mostly asked topic from this particular chapter is the aldehydes, the aldol reaction and the Cannizzaro reaction. So you have two reactions, aldol reaction. I am sure there will be one aldol reaction also been asked in this exam. So be ready with the aldol. They have asked about the Cannizzaro, then definitely you can expect an aldol reaction also. So there is an aldol reaction, there is Cannizzaro reaction, which is very, very important, and the test of identification is also very, very important. These are the ones which are commonly asked, very oftenly asked in JEE Advanced examination. Okay, so let's go for the Cannizzaro reaction. So Cannizzaro reaction and aldol reaction, if you see, they are two different reactions, and the conditions are very important. So in organic chemistry, when it comes to organic chemistry, the reactions, so in suppose if for JEE mains, if you are looking for the JEE mains pattern, it's quite easier. We get the questions, we just have to identify what reaction it is, the looking at the substrate, looking at the reagent what is given and the conditions given, we can give our answers, that is the product which they are asking. But when it comes to advanced examination, chemistry part, they will be asking, so there are questions asked on reaction mechanism. So it's not only the product which is important, it is the reaction mechanism which has to be learnt very properly, okay. And reaction mechanism, so you should be asking me now, should we learn all the reaction mechanism? No, the ones which are important, and your teachers know what to teach you. So they will give you those important, like for example, if I want to teach in aldehydes and ketones, these two mechanisms are must. So you should be learning the reaction mechanism of aldol reactions as well as Cannizzaro reactions, and you have different types of aldol and Cannizzaro reactions also, right. So the reaction mechanism is very, very important. There are very specific reactions whose mechanisms are from where the questions are being asked a lot of times. So those have to be learned very thoroughly, and this is one of them. So you should be knowing, you should be learning the reaction mechanism of aldol as well as Cannizzaro. Very, very important. So let's get into the Cannizzaro reaction now. The question is that the intermediate, so there is an intermediate, see, it's about the reaction mechanism. So this could be answered only if you have a clear idea about the reaction mechanism. Will be the best hydride donor, okay. So if I break down this reaction into 3 steps, so the Cannizzaro reaction happens in 3 steps. Basically, what is the Cannizzaro reaction? It is a reaction of aldehydes, okay. It is a reaction specifically for aldehydes, not for ketones. Not all ketones can participate in Cannizzaro reaction, only for aldehydes which do not have a alpha hydrogen, So aldehydes which do not have a alpha hydrogen in the presence of a concentrated base, okay, in the presence of a concentrated alkali solution, so if you take 2 molecules of that, 2 molecules of an aldehyde in the presence of a concentrated base, what happens is that one molecule gets oxidized to carboxylate ion, a salt of carboxylic acid, and you get an alcohol. So one molecule converting into an acid and one molecule converting into an alcohol. And if you can see, this is a redox reaction. It is a redox reaction where what is happening, tell me, there is a reduction as well as oxidation happening. And if you see, it is a disproportionate reaction. It is a disproportionate redox reaction where one molecule is getting converted into the higher form, the oxidized form, and the lower form, that is the reduced form, alcohol. So it's a very, very important reaction where you can actually generate 2 different molecules, that is the acid and alcohol from the aldehyde, okay. And I'll tell you why ketones are not so prone to this Cannizzaro reaction, right. So the conditions are what, tell me, aldehyde which does not have a alpha hydrogen, or you can say a non-enolizable aldehyde, which does not have a alpha hydrogen. Non-enolizable means you might have learned about the tautomerism, right. So in tautomerism, it is a sp3 carbon over which the hydrogen is there. There is a dynamic transfer of this hydrogen, right. So the tautomers, so there is enol form, right. The enol form of the aldehyde is the tautomer of aldehyde is enol form. So if there is no sp3 hydrogen available, there will be no tautomerism happening, so there will be no enolization. So these aldehydes without an sp3 what you can say alpha hydrogen, there is no enolized form, and hence we call these aldehydes as non-enolized aldehydes which does not have a alpha hydrogen, right. So now what is this alpha hydrogen? So you have the CHO group, and the carbon to which it is connected is called as the alpha carbon. So you have to look for the alpha hydrogen. So hydrogen connected to the alpha carbon to which the CHO group is attached. So the condition is no alpha hydrogen or non-enolizable aldehydes with concentrated base. In the case of aldol reactions, it is what? Aldehydes with alpha hydrogen. Aldehydes with alpha hydrogen in the presence of very less dilute base, okay. In the presence of dilute base, they undergo the reaction of condensation. So let's get into the Cannizzaro part. So what did we learn? So there are in this Cannizzaro reaction, there are 3 steps. What are the 3 steps? The first step is you can see there is attack of nucleophile. Since we have taken a concentrated basic solution, the base solution, we have the nucleophile concentration much available, which in this case will not go and abstract the proton, because there is no proton which it could abstract. So this will go and attack the carbon. So there is this nucleophilic attack over the electron deficient carbon. So this is the first step. So the first step is attack of the nucleophile. You can see over here, and there is a formation of dianion. So there is a formation of dianion, which is a very important compound. and this dianion is highly unstable molecule. This is a highly unstable molecule, and hence this dianion which is formed over here in the first step due to the attack of nucleophile will try to immediately convert into a stable one. How does it do? There is something called as, the second step is called as a hydride transfer. So this carbon has got 2 oxygen atoms with minus sign, which is highly unstable. So what happens? So this this negative charge wants to come back. So when this negative charge wants to come back, it has to leave away the hydrogen as H minus ion, right? So this is the step, and this is the rate determining step 2. So this is the step which is slower among all the 3 steps. First step is a bit faster, attack of nucleophile. Then this is the slowest step, and there is one more step which is the most fastest step of all the 3. So in the slowest step, if you see, there is something called as, this is called as a hydride transfer. There is a hydride transfer from the dianion to the next molecule. So we have used one molecule over here. This is the next molecule of aldehyde. So there is a hydride transfer to the next molecule of aldehyde, and you can see there is a formation of, what, tell me? So this dianion converts into a carboxylate ion, okay, by by the removal of H minus, and this H minus goes and attacks the carboxylic the carbonyl compound, and it forms the alkoxide. So we get 2 important compounds where in the second step, and this is called as a hydride transfer step, where we get a carboxylate and a oxide molecule. So now what's the next step? So next step, if you see, it is nothing but it's an acid-base reaction. Okay, it is an acid-base reaction which is quite fast. So this acid-base reaction or neutralization reaction, where there is exchange of H plus ion between the molecules, and this step is very fast. So there are 3 steps: attack of nucleophile. Then the second step is the transfer of hydride ion, which is the rate determining step, the slowest step, and the fastest one is the last step, which is the acid-base neutralization step. So now what's the question is about? The question is about the intermediate that will be the best hydride donor. It means they are talking about the second step. So they are asking about the step 2. And in step 2, you know that what are the things we are having? In step 2, it is the dianion. It is the dianion which is the most important intermediate here, right? So this intermediate, the dianion, if you look at the options over here, where the dianions I have one dianion here, B, and I have one here, D, and I have one dianion here over here. This is not a dianion, so this option goes away. So I am left with 3 options, that is B, D, and C. Okay, B, C, and D. So among the 3, if you observe, this particular dianion does not have any groups attached to this benzene ring. And here, if you see, there is an electron withdrawing group. There is an electron withdrawing group just opposite to that at para position. It is at the para position. Okay, and at the para position, if you see, there is an electron donating group. So how are this electron donating group at para position going to influence us? And we know that this electron withdrawing groups at para and ortho positions, they have something called as electron withdrawing groups. They have a nature of minus m. So they have this minus m or minus r nature, where they will what it will do, it will try to abstract the electron density from the system. So they are good at abstracting. So they are good at withdrawing the electron density from the system. And what about electron donating groups? They are good at giving the electron density into the system. So they withdraw and they donate, right? Now how is this 2 groups going to influence this? If you look at this particular step over here, it is, what, tell me? The hydride ion would come very easily whenever this charge falls back over the carbon. So when this charge will fall back over to this carbon, whenever this group, so this group which is attached, if it is an electron withdrawing group, so if it is an electron withdrawing group, it helps in abstracting the electron density. So this helps in this minus charge falling over to this carbon, right? So this is what we need. So it means an electron withdrawing group will determine the rate of this reaction. So because the rate of this reaction all depends upon this particular reaction. So the rate would be better. The rate would be better in this Cannizzaro reaction if there is an electron withdrawing group attached to this. And we can see that there is a withdrawing group attached in the option number D. So this is my correct answer, and this goes wrong and this goes wrong. Or if I say the rate of reactivity of all the 3, I would say the rate of reactivity will be so if I want to write down the reactivity order, they could have asked reactivity order also. Okay, so you can expect this kind of question in the next exam maybe. So what will be the reactivity order? It means this would be the most reactive because there is a group which is helping it to transfer the hydride very easily. So I would say D is the most reactive, and I say this is the one which will slow down the process because there is an electron donating group. So if there is an electron donating group, the minus charge would not come back very easily, right? So the highest is D, then I go with the B. So D is the highest, okay, then comes B and then comes C. So the most reactive in this particular reaction. So my answer is the intermediate, that will be the best hydride donor, or the one which is the most fastest reaction is the one with the electron withdrawing group, NO2. So that is all about the Cannizzaro reaction. So you can expect the same kind of questions in Cannizzaro as well as in aldol based on the reaction mechanisms. So that's very important to understand the reaction mechanism of important reactions. Okay, right. So let's move on to the next one. So there is, now this is a MCQ question, okay. So there is one important thing which I want to tell you is that, see, the questions which are being asked in JEE Advanced examinations are of, I would not say they are tougher level. They always try to check your concepts, how are you able to link the different concepts together, and they also check your presence of mind in the exam hall. So what do you mean with the presence of mind? So when it comes to the presence of mind, suppose I have seen some questions, when they get the paper, they straight away, start doing questions of maths, physics and chemistry. So in JEE Advanced exam, it is very important to first go through the instructions. That is the most important part for JEE Advanced, because the pattern is not, the same for all the years. It always gets changed. The pattern is always changing, and the pattern is always evolving, I would say. So you can expect a different kind of pattern every year. So this year the new pattern which you are going to get might be different than the previous one. Okay, so there is no guarantee that you will get the same kind of pattern. So it's very important for us to first spend the first few minutes. Okay, it will not take more than 5 minutes to go through the instructions. So once you go through the instructions properly, because the instructions are same for all the subjects, right? So go through the instructions properly. Section 1, how many marks are being awarded? Is there any negative marking? Okay, or my answers are multiple or single? That's very important. Okay, you have to look for whether it has a multiple answers or single correct answers, how many marks and how many negative marks. So first you have to analyze the paper. That's very, very important in the case of JEE Advanced. It's not the case of JEE Mains. In JEE Mains we have in JEE Mains also you have to go through the pattern, the instructions, but we can also predict the pattern also, like it will be always +4 and -1. So sometimes there will be a change, like this year we had a change. So but JEE Advanced, it's like always it is evolving, the pattern is always changing. So please make sure you go through the instructions first. That is the most important part before you start the exam. So once you understand the pattern of the exam, yes, so when you are doing a section, so section 1 when you are doing, so that particular points will be there in your mind. So when you are solving a question, yes, how much time you have to spend on this question, how many marks are you going to get, is there any negative mark, all these things will be already feeded in your mind, which is going to help you. Okay, so that's a very, very important thing before you start the exam, whatever the subject it is. Okay, but go through the instructions. So now we are going to do some questions under multiple choice questions. So multiple choice questions means you have to verify each and every option. You have to go through the options, each and every option, and you have to verify each and every word of that. So this is a question which is from the topic. From the topic, you can say it is from the topic solutions, because you can see there is a lot of things from molality, molecular weight. They're also asking us about the Van Hoff factor. So this is the question from solution chapter, and from the solution chapter, what are the topics that you can expect? You can expect a question from Rolle's law. Okay, basically you get a lot of questions on Rolle's law, especially in the integer type questions, the numerical type questions. You get a lot of questions. You also get questions from Van Hoff factor in integer type. So this is a chapter where you get questions in integer type. You also get questions on, like you got your MCQ here. You also get questions on single correct answers, like colligative properties. So the colligative property is the most favorite topic of this chapter, from where you can get a lot of questions. So this is a concept from the colligative property, so and Van Hoff factor. So let's see how do we answer this. And as I have told you, it will take more time. Multiple choice questions take more time. depending upon the concept which is there. For example, it is a physical, this is from the physical chemistry part where you have to verify each and every option. So let's go and verify each and every option of this particular question, right. So, so if you see the question, and one more important thing which I want to mention is, so when you're reading the question, see this question seems to be a bigger one in terms of the lines, so you have to be very careful with the data which is given. So the data which is given, if you collect them properly, 30 to 40% of the question has been done. The data is ready, you look for the concept using which you can solve, you can get the unknown, and then that's it, you get your answer. So that's very important to read the question with a cool mind, with a pleasant mind, okay, right. So if solution containing 2.1 grams of an organic acid, so there is one information given, so this acid, so there is an acid which is 2.1 grams. So let's write down the data first, so that's very important. So there is an acid, what is that acid? RCOH. So they have given an unknown acid and it is a monobasic acid. Since it is a monobasic acid, one clue is monobasic acid and it is 2.1 grams. So this is 2.1 grams. So 2.1 grams of this acid in 500 grams of water. So 500 grams of water. So 500 grams of water means nothing but it is 500 ml, right? Density of water is 1, so we can assume 500 grams as 500 ml. Shows a depression. So there is a depression in freezing point. How much it is? 0.156. So delta TF is given. So the next information is delta TF. Okay, so delta TF is given as how much? 0.156, 0.156 degrees Celsius. So this is a depression in the freezing point. Then what is the next information that I get? In the freezing point and 3 grams of the acid. So there is C. So from here there is the second part starting. That is the first part, this is the second part. So this 3 grams of acid, the 3 grams of this acid. So there is the second part now. So 3 grams of this acid. What acid? RCOH. So 3 grams of this acid. So this 3 grams of an acid could be neutralized. So I am doing a titration reaction between this acid, a weaker acid, and a salt here. Okay. So I am doing a titration here, and in the titration I have seen that I require this much amount of this Na2CO3. So we are doing a titration between this acid and Na2CO3. How much is the information given? It is 1 normal. It is 1 normal and 50 ml. 1 normal and 50 ml. So these are the titration values that they gave us. So using this, we have to look at all the options. And if you can see, the first question is based on molecular weight. There is a question based on molality. So when you read a question also, you have to look at the options, okay, not just blindly reading the question and start doing it. Look at the options, what they are trying to ask you, okay. So what is the link between the data what is given and the answers given? So if you can see here, there are a lot of different options given. So they're asking us about the molecular weight. First we have to verify the molecular weight. We have to verify the molality here, okay, which could be done with the help of the colligative property, and the degree of dissociation, because it is a weaker acid, right? Since it is a weaker acid, we know that electrolyte, we have learned that in Van Hoff factor. Van Hoff factor is meant for the electrolytes which can dissociate and associate. And since we have an electrolyte which is a weaker acid over here, it will definitely dissociate. So whenever there is a dissociation happening, the Van Hoff factor comes into the picture. So they are asking us about the Van Hoff factor. See, they are asking us about the Van Hoff factor, as well as they are asking us about the degree of dissociation. So this is a question which is trying to check a lot of concepts all together, and there are 2 parts in that. What is that first part? The first part is all about the depression and freezing point, and the next part, the second part, is all about the titration, what they have done. So why they have given 2 parts is because, so let's see, what do we need? Why do we need this? Because to find out what we have to find, the Van Hoff factor, right? So to find out the Van Hoff factor, see, there is an unknown acid given here. So since there is an unknown acid given over here, it's very important for us to know the concentration. So to find the concentration, that is about the molality, to find the molality part, we definitely need, what is molality? Tell me. Molality is nothing but number of moles of solute by the weight of solvent in kg, right? Or you can write the weight of the solute by its molecular weight into 1000 by the weight of the solvent in grams. Right, so this is the information, this is the formula to find out molality, and to find molality we need molecular weight. And how do we find this molecular weight? So to find molecular weight, we can use the Van Hoff factor, or we can use this data. So this data which is given actually is to find out the molecular weight. So we have to find out the molecular weight in this case. Now how can we find out the molecular weights in the case of titrations? Just now in the first question of this session we have learned how to find out how do we what is the law that we apply for titrations, right? So what can we do? So I can see that there is a titration between this 3 grams of acid with Na2CO3, and I know the information about normality and volume, right? So what I'm going to use? I'm going to use the equivalent concept, the law of equivalence. So with the help of law of equivalence, I can write the equivalence of this acid consumed will be equal to the equivalence at the neutralization point, at the equivalent point, at the equivalence, you will see that the equivalence of RCOH, the acid, the weaker acid consumed will be equal to the equivalence of Na2CO3. Okay, and we have learned the different ways in which we can express the equivalents. What are the different ways in which we can express the equivalents? It is the gram equivalence is equal to normality into volume, or it could be molarity into volume multiplied with n factor, or it will be n factor into number of moles, or it could be weight by equivalent weight. Weight by equivalent weight. So let's find out how can we find out the molecular weight, right? So let's find out the molecular weight of this particular compound. So in the place of, see, the question is about I want to find out the molecular weights, right? So what I will do is that I will use this formula, because once I use this formula, in the place of equivalent weight I can write molecular weight by n factor. Okay, so equivalent weight is equal to molecular weight by n factor. This is what I can write down. And in the case of RCOH, what type of acid it is? It is a monobasic acid. It is a monobasic acid. Since it is a monobasic acid, the n factor is equal to 1. The n factor is equal to 1 in the case of the monobasic acid. So equivalent weight is equal to the molecular weight of this particular acid. So I'm going to apply this formula. What is that? The equivalent weight of this, the weight of RCOH, the acid, the unknown acid, by its equivalent weight, okay, is equal to Na2CO3. What is the information about Na2CO3 given? It is 1 normal. So it is 1 into, so 1 normal into what is the volume? It is 500, or it is 50 ml. Am I sure? It is 50 ml. Yes, it is 50 ml. So 50 ml can be written as 50 into 10 power minus 3. 50 into 10 power minus 3, because it should be in liters. So from here, what I am going to do, it is the weight of this acid. What is the weight of this acid given in this particular titration? It is 3 grams. Don't use this 2.1 grams. It is the 3 grams of this titration part. There are 2 parts which I told you, right? So it is a 3 grams. So you might be doing a mistake taking the 2.1 gram here, and definitely you get a wrong answer. So it is a 3 grams which is used in this titration. So 3 grams of this. So 3 grams of this divided by the equivalent weight, and I have shown you that for this particular acid, monobasic acid, equivalent weight is equal to the molecular weight. So what I am going to write here, so in the place of equivalent weight I am going to write down its molecular weight, because equivalent weight is equal to the molecular weight, because it is a monobasic acid, so n factor is 1. So it is equal to it is 50 into 10 power minus 3. So on solving this, you will get the molecular weight of the acid. Which one? RCOOH. The molecular weight of this acid as 60 grams. So we got the first one. What is that? 60 grams. So let's go for the options. So what is the molecular weight of acid given? It is 40 grams, which is the wrong answer. So it is 60 grams. So I found out my molecular weight of this unknown molecule, unknown acid, the weaker monobasic acid, as 60 grams. So this is my first answer. So once we are ready with the molecular weight, we can immediately find molality. So let's go and find out the molality and etc. So now so this part is over. So this was actually used to find out the molecular weight of this particular compound, which is RCOH, which is 60 grams. So now get back to this particular part, the first part, which is the colligative part. Now what are the other things which are included? See, all the others are included. All these 3 could be done with the help of colligative properties. So now we have to find out what, tell me, we have to find out the molality, we have to find out the alpha, and we have to also find out the I value. Okay, so let me go back to the formula of colligative property. What is the formula of delta colligative property? This depression in freezing point, delta TF is equal to I. Don't forget the I. It is must in the case of an electrolyte or the solute which can dissociate or associate. So I is I into Kf into molality. So this is the formula which could be applied in the case of depression in freezing point. And what is the delta TF given? So from this question I can easily find out what, tell me, I. So to find out I, so I is equal to what? I is equal to delta TF delta TF by KF into molality. So, this is what I can use to find out the I value. And to find out the I value, if you see, do I have all the informations that are needed for this particular thing? So, for delta TF, do I have delta TF? Yes, I have the delta TF value. What is the delta TF value? 0.156. So, this is 0.156, okay, degrees Celsius. And what is the KF value? I think the KF value is also given. For KF value, so since the KF value is not mentioned here, for water, since they have mentioned this as water, for water it is 1.86. So, the KF value for 1.86, it is 1.86. It will be given in the question, you don't have to worry. So, 1.86. So, I know delta TF, I know KF value for water. So, this is for the water case, okay. Now, how do I find molality? So, to find out the Van Hoff factor, I need to know the molality. And what is the formula of molality? Molality is equal to weight of that substance into divided by its molecular weight into 1000 by the weight of the solvent in grams. So, this is the formula for molality. So, how can I do this? So, what is the weight of this particular solution? So, you have to come back to this solution now, okay. So, this is the solution of two liquids or a solute into a solvent, 2.1 grams into 500 grams, 2.1 grams into 500 grams. So, let us get back to this. So, it is 2.1 grams. So, 2.1 grams of this acid divided by its molecular weight is 60 grams into 1000 by, what is the weight of the solvent? 500 grams, or we can say 500 into, okay, it is 500 grams, right? Yeah, 500 grams. So, this is your molality. Okay, and when you solve this, you will come across this molality to be equal to 0.07 molal. So, it will be 0.07 molal. Yes, my answer is option number D. So, on solving this, you will be getting the answer as 0.07 molal. It is not meters, it is molality, right. So, once your molality is ready, so how much is the molality? It is 0.07. So, you have all the things ready with you. You have the delta TF, which is 0.156, which is KF is 1.86, and you have the molality ready, that is 0.87. So, your I value will be how much? So, your I would be yeah, so your I would be you will get this as 1.2 because it is a weak acid. Definitely, see, it is a weak acid, right? We are talking about RCOH. So, when we talk about RCOH, it will ionize into what? Tell me, RCOO minus and H plus. So, it will ionize in this fashion, right? And it is a weaker acid. So, it will be greater than 1 but not more than 2. So, that is why you got the answer as 1.2. So, this is your I value now, okay. So, are we done with this? No. So, we are done with option number B, which is the correct one. I got my molality as 0.07 and I got my I value also as 1.2. So, option number D is also correct. I got my I value also as 1.2. Now, there is one more option. What is that? We should also find out the degree of dissociation of the acid. So, how can you find out the degree of dissociation of the acid? So, now I will give you some formulas, like whenever you want to find out the Van Hoff factor whenever the solute is dissociating. So, whenever the solute, okay, dissociates. So, whenever the solute dissociates, what are the Van Hoff factors that you will expect? So, a solute which is dissociating, it could be a stronger one, a stronger electrolyte, okay, a stronger electrolyte, or it could be a weaker electrolyte, or stronger electrolyte. So, if it is a stronger electrolyte, what will be the I value? Obviously, the I value is equal to what? It will be equal to N, okay, it will be equal to N. What is this N here? It is the number of dissociated ions. For example, NaCl, okay. So, what will be the I value for NaCl? NaCl being a stronger electrolyte, NaCl will dissolve into the solvent water, into a polar solvent, and it will get what are the ions which we will be getting? We will be getting Na plus ion and Cl minus ion. So, I value is equal to 2. So, 2 ions, it is able to produce 2 ions upon dissociation, right. So, it is the number of dissociated ions. It means after adding it to a solvent. It means after adding to a solvent. After adding it to a solvent, the number of particles available is N. So I is equal to the number of dissociated particles in the case of stronger electrolyte, and in the case of weaker electrolyte is I is equal to 1 plus n minus 1 into alpha. I is equal to 1 plus n minus 1 into alpha, and you already know what is n over here. N is the number of dissociated particles after adding it to a solvent, and what is alpha? Alpha is the degree of dissociation, because we are talking about the dissociation of a weaker electrolyte. So degree of dissociation. Right. So this is how you can find out the Van Hoff factor in the case of electrolyte which dissociates on addition to a solvent, on addition to a liquid. So this is the case of dissociation. You also have the case of association also, okay, where something called as degree of association comes into picture. And you also have the electrolytes which do not ionize. The ones which do not ionize, I value will be equal to 1 for non-electrolytes. This is for non-electrolytes. I is equal to 1. So now which formula am I going to use now? Tell me. It is a weaker electrolyte. RCOH is a weaker electrolyte. So for the weaker electrolyte, I am going to use this formula. I is equal to 1 plus n minus 1 into alpha. So what is the I value that I have found out? So just keep in your mind the I value that you have found out. I is 1.2. So I is equal to 1.2. So what you can find out? So here you can find out I is equal to 1 plus n minus 1 into alpha. Okay, and what is the I value given? I value is given as 1.2. N values tell me RCOH will dissociate into 2 ions upon adding. So N value is 2 because it will dissociate into the RCOO minus, the carboxylate, and the H plus ion. So 2, and we need to find out the alpha. So what will be the alpha value here? So alpha is equal to, it will be equal to I is equal to 1 plus 2 minus 1 alpha means 1 plus alpha. Alpha is equal to I minus 1. Okay, so which is how much? I minus 1 is, alpha is equal to how much? Alpha is equal to, I value is 1.2, 1.2 minus 1 is 0.2. So the alpha value which I got, is 0.2, or we can say the percentage dissociation is equal to 0.2 into 100. Percentage means into 100. So 0.2 into 100 is 20%. So let's see if my option has this alpha value as 0.2 or the degree of dissociation, the percentage degree of dissociation as 20%. So let me go for the option. The degree of dissociation of the acid is 2%. It is not 2%, it is 20%. So this is a wrong option. So my correct answers are B and D. So finally, we have done this question. See, this question, you might think that this is taking a lot of time. No. If you are ready, if you have understood the question, see, once I understood the question, once I have read the question and understood that there are 2 parts, this would not take much time. So if you have understood that there are 2 parts and what is the use of the second part, find out the molecular weight, use the molecular weight in the colligative property. You will not take much time because you just have to use which formula? Here we have used the colligative property formula where I have to find out the molality. So find out the molality, use the molality over here to find I, and with the help of I you are finding alpha. Okay, so that was a question which was actually a very important question which is covering up a lot of topics over here. So they are checking whether you know the concept of Van Hoff factor, how do we find out in the case of dissociation. They are also checking how do we find out colligative property formulas, whether you know the colligative properties, Van Hoff factor. They are also trying to check whether you are good with the concentration terms like molality. Okay, and they are also trying to check whether you are good with the law of equivalence, the titration. So there are 4 to 5 different concepts which are linked at one question. So it takes time. Okay, it takes time, but believe me, MCQs are the ones which will give you correct answers. Okay, so you have to spend more time at MCQs and you will definitely get a correct answer. Okay, and you can see that sometimes the IIT, the JEE Advanced, they also make sometimes the MCQs as negative free. So it is also an advantage for us. So whenever it is negative free, you should always give your 100% at those questions. You have to try them. So whenever there is a section with negative free, it is a negative free means there are no negative marks. So always try to target those sections where there are no negative marks, because if you spend time, if you try them, there are chances that you can get a correct answer. Okay, so if it goes wrong also, nothing wrong with the negative marks. So always try to look for those section of questions which have no negative marks, negative free sections, right? And I have seen a lot of cases there where the multiple choice questions are being with integer. Nowadays you get integer type also negative free. So always target those type of sections. Okay, we have one more multiple question from organic part. So this is a question from your GOC. Basically, it deals with the isomerism part. Okay, from GOC, that is a general organic chemistry, the basic concepts of organic chemistry, where you come across concepts like stereoisomerism. So among the isomerism, the most important part is the stereoisomerism part, where you have again three parts: configurational, the conformational, and we have the geometrical and optical. So the most important one I would say is the optical part, where you get a lot of questions because there are chemical reactions, organic chemical reactions linked with optical isomerism. So optical isomerism is the first most important one, then comes the geometrical isomerism, and then we can say a question from your conformers also. So this is a question from your optical isomerism, and like it is trying to check all the isomerism part together. So what is this question about? So they give you a molecule which is present in vitamin C, and they're asking us few questions. See, and if you can see the questions here, they're asking us about the chiral centers and optical isomerism and tautomerism. Okay, so two types: optical isomerism and tautomerism. And what is this one? It contains a carboxylic acid group. Does it contains a carboxylic acid group? Let me look at this. Do I have a carboxylic acid? I don't think. I have all of them as OH, 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 and I have an ester group here, COO. So I don't have a carboxylic acid group. Okay, so this option is completely out of my context. Okay, so I am left with three options. Can show optical isomerism. See, these two are linked. If it can show optical isomerism, then I have to check for how many chiral centers. Okay, so let's check for each one. So this is the molecule which they gave us. So to check the optical isomerism, we have to look for the chiral molecule. So chiral molecules or the chiral carbons, right? So what is this chiral carbon? The carbon which is asymmetric, or we can say a sp3 carbon with all the groups around it different, which does not have a plane of symmetry. Okay, a carbon with all the groups different, a sp3 carbon with no plane of symmetries. A asymmetric carbon, you can say a asymmetric, or you can say non-planar molecule. So let's look for this asymmetric carbon. I'll put that carbon with a star mark. Okay, right. Right. So if you see, I could see an sp3 carbon over here. Okay, I could see an sp3 carbon over here and here. So if I look at this carbon over here, I have OH group here, I have this methyl OH and this complete thing and hydrogen. So I would say this is a carbon which I found out which is asymmetric. Okay, then I have one more carbon over here. Okay, so this carbon, do you think? So there are two hydrogens attached. So this carbon will not be a chiral carbon. I would say this particular carbon is chiral. So I can see two chiral carbons. Okay, which is asymmetrical, or you can say there is no plane of symmetry. So I can see there are chiral carbons present, and it is an asymmetric molecule. So it is optically active. So since it is optically active, it will have its optical isomers. And what are the optical isomers we have? The enantiomers of this particular are the optical isomers, right? So the question can also be asked like how many optical isomers. So if they ask you the number of optical isomers, if they ask you about the number of optical isomers, how will you find out? So there are different formulas are there. The basic formula is 2 power n. The basic formula is 2 power n whenever the molecule is or you can say asymmetric molecule. If the molecule is asymmetric, then we say you can use the formula 2 power n. And what is this n over here? N is the number of chiral centers, or you can say the number of stereo centers. And how many do I have? I have two carbons which are chiral. So 2 power n, or you can say 2 power 2. So 2 power 2, I have how many? I'll have 4 isomers. I have 4 optical isomers in this case. Okay. So let's go for the options. Yes, it is optically active. And how many chiral centers does it have? It has 1? No, it has 2 chiral centers. So this option is wrong. Okay, option number B is correct. Option number A is wrong because it has 2 chiral centers and total number of isomers are 4. 2 power 2 for an asymmetrical molecule, it is 2 power n, and n is the number of chiral carbons. Right. There is one more option which they are asking us to check the tautomerism. Now what is this tautomerism? Okay, but what is this tautomerism? So this tautomerism, you might have come across this tautomerism whenever you come across a system where you have the double bond between A and B, and there is this hydrogen, sp3 hydrogen. It's called as the enolizable hydrogen. So this enolizable, or you can say this is a hydrogen which can get tautomerized very easily. So there is a dynamic shift of this hydrogen from one atom to the other atom. So this will tautomerize into what? So this will tautomerize into A B double bond C, and the H would be here. So there is a dynamic transfer of this proton from one atom to the other one because of this conjugation, which is between the conjugation between the orbitals. So this is called as a tautomer. So for tautomerism, what is the condition? Tell me. So double bond, okay, the pi bond, and the next carbon should be an sp3, and there should be this sp3 hydrogen available. Okay, so hydrogen which is connected to an sp3 atom. So let's look for those things. So there is a double bond over here. So there is a double bond over here, and do you see tautomerism anywhere? Do I have any carbon which is having an hydrogen? So this side we don't have any carbon, no carbon. This carbon does not. This is an sp2 carbon. And what about this one here? So here, if you see, there is an hydrogen over here because this carbon is 1 here with oxygen, 2 here, 3 here, and there will be a hydrogen here at this particular carbon, right? So it means this hydrogen can be involved in this enolization. So this part can be enolized, or we can say tautomerized. So the answer is correct. So it can show tautomerism. Okay, it can show tautomerism because there is a presence of this dynamic hydrogen which is available over sp3 carbon. So sp3 carbon, and I have that hydrogen available. So yes, so I'll go with two options, that is B and C. So B and C are my correct answers. Yes, it is optically active. It does not have 1, it has 2, and it is tautomer, and it shows tautomerism. So this is how they are trying to check the isomerism part altogether. So you can get a question here including the geometrical isomerism also. For geometrical isomerism, you have to be very careful with the conditions that the same carbon should not have the same groups connected. Right. So this is how you can expect a question from optical isomerism, not optical isomerism, I would say stereoisomerism. It's a very important topic when compared to the structural isomerism. Right. So the next question is on is a numerical type of question. So how do we solve this numerical type? So this is a question from your inorganic part. So from inorganic part also a numerical can be expected. It's not always a theoretical kind of questions. You can always expect a numerical kind of question from your inorganic part. So this is a question from your inorganic. So let's see what are the things they are asking us. How many oxygen atoms are present in a cyclic ring of solid potassium bicarbonate? So solid potassium bicarbonate. That is a hint they gave us, solid potassium bicarbonate. So what do we know about this? So we know the formula. What is that? Potassium bicarbonate. Or this could be written properly as what? This could be, if you write down this in an ionic form, this is nothing but HCO3 minus and K plus. And if I have to write down more properly in terms of the structure, it is something like this. You have O, okay, then you have the OH, you have the O minus, and you have the K plus. So this is your ionic potassium carbonate. Bicarbonate, okay. So this is your potassium bicarbonate. They're asking us the cyclic ring. So they gave us the entire information actually, okay. So we don't have to worry about this. So cyclic ring of solid potassium bicarbonate. Now what is this cyclic ring of potassium bicarbonate? This is there in your NCERT book. So you can get this line from your NCERT, that the solid form of this potassium bicarbonate, the cyclic ring, it exists as a dimer. So you will expect this to be a dimer in the form of solid, okay, the dimer. This exists as a dimer. So this is a very important question too, which is there, which has been asked in a lot of competitive examination. So what is the dimeric structure now? So if I have to write down the dimeric structure, so I have the carbon over here, let's say the double bond here, let's say OH over here, then we have the O minus, okay. Then let's say the other one, carbon here, O here, okay. Let's say O minus over here and OH over here. And if you see here, there is a concept of hydrogen bonding. So what is this? So there is an interaction between these two. So this is called as the hydrogen bonding. And you know the concept. What is hydrogen bonding? The hydrogen bonding is nothing but the hydrogen attached to the more electronegative atoms like nitrogen, oxygen and fluorine. So the hydrogen connected to the more electronegative atoms like nitrogen, oxygen and fluorine is highly polarized, because of which it starts interacting with the electronegative atom of the partial negative end of other molecules. So this is called as a hydrogen bonding. So there is a hydrogen bonding possible between the highly polarized hydrogen of this OH bond, because it is along with the oxygen. So this end starts interacting with the negative part. So this is called as a hydrogen bonding. So because of the hydrogen bonding, it forms a dimer. That's a very important question. And it's a what? Intermolecular hydrogen bonding, because between two molecules, there is intra and there is inter. So this is a kind of intermolecular hydrogen bonding, and they're asking us the number of oxygen atoms present in the cyclic ring of this solid state. So if you look at the cyclic ring of this solid state, cyclic ring of this dimer, how many oxygens are involved? This oxygen is not involved, this oxygen is not involved. So it means this oxygen, this oxygen, this oxygen and this oxygen is involved in the cyclic ring of the solid bicarbonate. So my answer is what? Tell me. The answer is 4. It is a numerical type question, right? So this is a question from inorganic, where we do not expect a question in terms of numerical, but there is a numerical which has been asked. So you have to be very careful with the concept. Here it is not about the number, it is about the concept. You can look at the concept over here, right? So let's move on to the next one. Right. So the next question is about a stoichiometry. So this is a question from stoichiometry, which is one of the favorite for all the teachers who are preparing it. So in JEE Advanced, always you will find one or the other question related to the moles, mole concept or stoichiometry for sure. And in stoichiometry, if they are giving you a question, it will be definitely from limiting reagent or composition reactions or percentage yield. So this is a question based on your limiting reagent, and they gave us the reaction. Okay, so they gave us a reaction where sulfur dioxide, you have H2S giving us the sulfur and water. So we need to solve this. We need to find out what? We need to find out the number of moles of sulfur formed. We have to find out the number of moles of sulfur formed. X, we have to find X, and they're asking us what is 2X. Okay, so they have made it 2X. So let's find out the X part. So before we start doing this, limiting reagent concept, how to do this? So the reaction is what? Tell me. We have SO2, and you can see it is a balanced reaction where according to stoichiometry, 1 mole of this reacts with 2 and gives us 3 moles of this and 2 moles of this. So this is the ratio in which they are reacting and formed. Okay, so now let's do according to the limiting reagent concept. So the participants are what? Tell me. I have one SO2 molecule. I have one SO2, I have H2S, I have sulfur and water. Okay. First we will start up with the, let's start up with the stoichiometrical ratio. So what is the stoichiometrical ratio in which they are reacting? The stoichiometrical ratio. Okay, the stoichiometrical ratio in which they are reacting, it is 1, 2, 3 and 2. So 1 mole reacts with 2 moles, gives you 3 moles and 2 moles. Okay. Now what is the next one? The next thing is what is given in the question. What is given in the question? The given number of the amount of substance. So if you see, the amount of substance given is 2 moles of H2S. They gave us 2 moles of H2S. Okay, but with 2 moles of H2S, I require how much? Tell me. I require 1 mole of SO2. But how much did they give us? They gave us 11.2 liters of SO2 and at NTP. So SO2 given is how much? It is 11.2. So SO2 gas taken is 11.2 liters, which is exactly equal to how much? 0.5 moles. Because if you can see, 22.4 is equivalent to 1, it's called as a molar volume. 22.4 molar volume is for 1 mole of a gas, and this 11.2 is meant for 0.5 moles of a gas. So they gave us the information about SO2 as 0.5. And you can see clearly what is the limiting reagent, the one which is given in a limited amount or the one which gets consumed very quickly in a chemical reaction. So 2 requires 1, but with 2 moles I have given only 0.5. It means this is my limiting reagent. So this is my limiting reagent, and this is the one which is taken in excess. Right? So done. So if this part is done, then we can go for yeah. So if this part is done, then we can go for the actual reaction now. So limiting reagent is the one which is going to govern the reaction. It means what? Tell me. So the complete reaction will be now governed by the limiting reagent. So because the one which is consumed quickly will govern the reaction, means it will stop the reaction quickly. It means the amount of reactant that has to be reacted, the amount of product which has to be formed will all be governed by the amount of limiting reagent, because it is taken in limited amount. If it gets over, the reaction stops. So now, since I have taken 0.5, so let's write down first how much is reacting. Okay. So how much has reacted? How much reactants have reacted? We know that limiting reagent is the one which will be completely consumed. So it means 0.5 moles of this SO2 will be completely consumed, and with 0.5 moles I just need only 1 mole, because 1 requires 2, then 0.5 will require exactly half of that. So I require only 1 mole of H2S. So 1 mole is in excess. Okay, so done. So this part is also done. Now the next one is how much has formed, the products formed. Okay, so what are the products formed now? The products formed are sulfur and H2O. How much it will form, tell me? With every 1 mole of SO2, you get 3 moles of sulfur. With 1 mole, you get 3 moles. With 0.5, how much you will be getting? Obviously, half of that, it will be 3 by 2, which is this one. So you will be getting 3 by 2 moles of sulfur, because exactly half of that, because the limiting reagent is taken exactly half of what is required stoichiometrically. And this will be exactly half of that, that is 1. Okay, so done. Now what is leftover? Okay, nothing but leftover. So what is leftover? Leftover reactant. So the leftover reactant. So what is leftover? Tell me. The one which is in excess. So it means I have taken 2 moles of this. So 2 moles minus 1 mole, which is nothing but 1. So 1 mole of H2S will be left over along with the products. How much is the product formed? It is 3 by 2 moles of sulfur and 1 mole of H2O. Along with this, you will have 1 mole of H2S left over after the reaction is completed. So what is the question about? The question is the amount of sulfur formed. So the amount of sulfur formed is X. So this is X. The amount of sulfur formed is X, and they are asking us about what, tell me? So X is equal to 3 by 2 moles. And they are asking us about 2x. So what is 2x here? It is 3 moles. So my answer is 3. So it is a question basically from stoichiometry, and that too from a very important topic, that is limiting reagent. So whenever you are doing a limiting reagent, first you have to identify the limiting reagent. And how do we identify? There is a small trick also, I will tell you how to find the limiting reagent. So the limiting reagent is the one where the given amount, when you divide the given amount divided by the stoichiometrical amount. Okay, so just divide the amount of the given substance divided by the stoichiometrical requirement. Here in this case, if you see for SO2, so I want to check in the case of SO2 and in the case of H2S, I want to know which is a limiting reagent. So the given amount for SO2 is how much? 0.5. So 0.5 divided by what is stoichiometrically required, it is 1. And for H2SO4, 2 was given and 2 was required. Okay. So wherever you get this number less than 1, whenever you get this number less than 1, that particular thing is a limiting reagent. So wherever the given amount divided by the stoichiometrical requirement is less than 1, that particular answer is your limiting reagent. You can see clearly I am getting this as less than 1. So this is equal to 1, right? And this is less than 1. So this is less than 1. So this is my limiting reagent. So that's a trick. Whenever you have more than 2 components, it's quite difficult for us to compare. So whenever you have more than 2 components, whenever you have more than 2 reactants, this is the trick to find out the limiting reagent. You just have to divide the given amount of that substance divided by the stoichiometrical requirement. And the one which yields you a smaller fraction, the smaller fraction is your limiting reagent. The smallest fraction is your limiting reagent. In this case, I got 0.5 in the case of SO2 and 1 in the case of H2S. So 0.5 is the limiting reagent, that is SO2. So to identify, once you identify the limiting reagent, then the reaction is very simple, because according to the limiting reagent, the entire reaction will proceed, right? So with respect to this thing, you will get your reactions done. So this part is the most important part. Clear? So this is about your question, a question which has come based on mole concept. Okay, right. So there is one more numerical value which has come from the chapter called a solid state, and this is a chapter which everybody likes, because this is the first chapter of your 12th and everybody knows each and every concept of this chapter. So there is a very easier question which was given, which is based on the limiting radius ratio. And what is the question about? So they gave us the radius of the cation. So they gave us the radius of the cation and they gave us the radius of the anion. Okay, so we just have to find out the radius of the cation by radius of anion, and we have a table in our NCERT book. So this radius of cation by radius of anion will tell us to know what type of packing is being done in the ionic compounds. The type of ionic compound packing, the packing in ionic compound, the geometry of this unit cell, the molecule is all dependent upon this radius. It's called as the limiting radius ratio. So based on this, you can answer this. So just you have to find out the ratio. So 95 given, by how much is that? 181. So when you divide this, you will get approximately as 0.52. So this 0.52 is which falls. So you have a table in your NCERT book. From this NCERT table which is there, you can answer this question very easily. What are the questions? Tell me. So this 0.52 lies in this range, right? So 0.414 to 0.732. So now you can answer a lot of other questions like what could be the coordination number of this kind of ionic compound taking this structure. So what would be that? It would be 6. But what are they asking us? They are asking us about the coordination number. So coordination number of the cation will be 6. Coordination number of the cation as well as the anion would be 6. So this table is from your NCERT book. It's not from something made up one. It is from your NCERT. So JEE Advanced exam does not give you something out of the box. Yes, it tries to ask you questions which are completely application oriented, but the lines starts from your NCERT. So always try to stick with the NCERT lines and try to build up concept over those lines. So you have a lot of questions. You have to do a lot of numericals which will help you understand the application part. So this is how you can apply the simple concept of limiting reagent, and you can find coordination number as well as you will also get to know what type of geometry is that, okay, and the molecules. And we have learned this, right? Rock salt type of structures, NaCl type of structures. So that's all about the numerical questions. So we have got yeah. So in this way we can go on discussing a lot of questions from our JEE Advanced. The theme is very simple. For chemistry, it is always make your concept clear by reading your NCERT. Yes, NCERT is not enough for JEE Advanced, that's true, but you can take the base of NCERT, because in JEE Advanced exam, it's not that all the questions are application oriented. No, there are questions which are easier ones, and these easier questions are from your NCERT book. Okay, I would not say all of them are easier. I would say it's 20% to 30%, I would say 25 to 30% questions which are easier from your NCERT. So to get a rank, to get qualified for your JEE Advanced, you don't have to score, you don't have to solve all the questions. You just have to score in such a way that you get qualified and get a good rank, right? So for the students who feel chemistry is difficult, first the thing is you have to start with your NCERT lines. Be thorough with all the questions which are from your NCERT book, because once you do the NCERT book, once you are thorough with the different models of questions from your NCERT, you are actually you have covered up the easier part as well as the moderate part. You are only left with the difficult questions. These difficult questions are the ones which are linked up questions, like you have multi concepts. Like I have told you, in electrochemistry it could be linked with redox, it could be linked with thermodynamics, it could be linked with equilibrium chapter. So the difficult part which is there will not be too many. So out of, let's say 50 questions, you will not get more than 10 questions. You will hardly have 10 questions which are challenging questions and which are based on connecting concepts, multiple concepts. So always target the easier and moderate, and definitely you will be able to qualify the exam. And believe and always remember that chemistry is always the scoring part. So always try to target chemistry, get good marks in your chemistry. The overall score will definitely look good, and it is like it will make your score look better. So that's it from the chemistry part. Now I would like to request our maths faculty Sudhakar sir. He will now continue with the maths discussion of your JEE Advanced paper, and thank you.
Hello students, good afternoon to everybody. I hope you enjoy the physics and chemistry session. I hope you understood all the solutions. Now we will discuss the mathematics part. So whatever the questions given in a mock test which is held on 19, we will discuss that questions now, right? So we'll see the questions. First one, single correct answer type questions. After that, we will see multiple correct, more than one correct answer type. After that, we will see integer type or numerical based questions. We'll see passage type questions also. So we'll see first single correct answer type questions. So this is the first question of single correct answer type. So they given if a equal to x is such that minus 2 less than x less than 4, x belongs to z. So what does that mean? They given integers. We have to select the integers from this interval. Minus 2 less than x less than 4. Then the number of proper subsets of A is, right? So first of all, to find the number of proper subsets of set A, we need some elements. We need the elements of A, right? So what are the elements of A? A is given in the form of, this is set, right? It is the property method of the set. So we have to write the roster form for this set. Roster form. So what is the roster form? You can see here, the roster form is A is equal to, you can see we have to write the integers from this interval, right? What are the integers are there? So minus 1, right? 0, 1, 2, 3, right? So these are the integers are there in this interval. So this is called roster form or list method of the set, given set. Now number of proper subsets of A. So how many number of subsets can be made? How many number of subsets can be made? So we will write all the number of subsets. We'll find how many number of subsets can be made by using this set, right? So you can see here, if you take the blanks like this, so how many elements are there? There are 5 elements, right? 5 blanks considered. So first blank here, you can see, you can take this element to make the subset. You can take the element minus 1 or may not be taken the minus 1, right? So what are the subsets? You can see the example minus 1, you can write the minus 1 as a one subset, and you can write 0 as a one subset, right? You can write the elements minus 1 comma 0 comma 1 as a one subset. You can make many subsets like this. So how many we can make by this? With the help of this set, how many subsets can be made, right? So that can be find like this. You can see to make the subset, we can take any number of elements. Any number of elements can be taken from this set. So we may or may not be taken particular number, right? Particular element of the set. So how many possibilities are there for the number minus 1? For the element minus 1, there are 2 possibilities, right? So 2 ways we can choose this minus 1. Similarly, 0 also can be taken in 2 ways, right? So this has 2 choices and 1 has 2 choices, which may or may not be taken. That is the choice, may or may not be taken. So there are how many choices? Right, for each element has 2 choices. There are 5 elements. There are 5 2's will come. Right, 5 2's multiplied by 2 5 times. So this can be written as 2 power 5. So out of these subsets, there are 2 power 5 subsets are there. Out of these 2 power 5 subsets, there is one subset which consisting of all the elements. Right? So along with empty set. So whenever no element is considered, element set is formed. Whenever all the elements are considered, right? So that is, it is improper subset. So what is the subset? Subset of A. Subset of A. The set itself is a subset of A. That is minus 1, 0, 1, 2, 3. So this is, it consisting of all the elements, right? So this is a subset of A and it is equal to A. So every set is a subset of itself, right? Now, they are asking proper subsets. What is this? This is improper subset, right? So what is improper subset? The set itself is called improper subset. So we required only number of proper subsets. number of proper subsets. Number of proper subsets. That is equal to total number of subsets. Total number of subsets minus improper subset. There is only one improper subset for every set, right? The set itself is called improper subset. So improper subset. So what is improper subset? Now in number of improper subset, number of improper subset you can write number of improper subset. Improper subset. So there are only one improper subset is there which consisting of all the elements, right? So this is improper subset. The set itself is improper subset. So total number of subsets are 2 power 5 and improper subset is 1. So answer is 2 power 5, 32 minus 1. So the answer is 31. So 31. Now how many number of subsets can be made? 31 subsets can be made by using this set, right? So the answer is first option. Now we'll see the next question. So this question, if roots of quadratic equation 25x square minus 51x plus 2 equal to 0, satisfying the equation 3px minus 2 equal to 0, then sum of all possible values of p. Then sum of all possible values of p. So how can you do this? So roots are satisfying this equation. So it's very simple question in single correct answer type. So you have to solve the equation, find the roots and substitute that values of x in this x. In this equation, you will get the answer p, right? So now we will do that. So what is that? Factorization. Factorization of quadratic equation. 25x square minus 51x. So 25x square minus 51x plus 2. So this is the quadratic equation, right? Now factorize this. So this is, you can see, so two numbers. When you multiply two numbers, the product must be the coefficient of x square and constant term. The product of coefficient of x square and constant term is 50, that is equal to AB. We will take another two numbers, means same two numbers in the form of addition, a plus b, whose sum must be middle x coefficient. What is x coefficient here? Minus 51. So in this way we can split the quadratic equation, right? Splitting the middle term. We will find the factors of quadratic equation using the method of splitting the middle term. Splitting the middle term. So how I got this? 25 into 2, 50. That is the product of two numbers. And the middle one is minus 51. That is addition of those two numbers. Now, whose two numbers are satisfying this equation at the same time? So that we have to identify. What is that? A is equal to minus 50 and b is equal to 1, minus 1. You can take these two numbers. You can take a b equal to minus 50 or a is equal to minus 1. You can take in any two numbers, right? You can take in either way. Now, so I got the two numbers whose satisfying, these numbers are satisfying the given equation. So now with the help of this, I can split the middle term. So that is minus 51x can be written as minus 50x minus x plus 2 is equal to 0. So I am splitting the middle term, remaining two terms writing as it is. Now factorize, common thing. What is the common thing between these two? So 25x is common, 25x is common, x minus 2, right? X minus 2. Now minus 1 is common, x minus 2 is left. Now what is the common thing? X minus 2 is common. You are left with 25x minus 1 is equal to 0, right? Now, so we whenever equated each of these factor to 0, we will get the two roots, right? When a product is 0 means any one of them must be 0, right? X is equal to 2 or x is equal to 1 by 25. Now, we'll see here. What is the given equation? 3px minus 2. What we got? X is equal to 2, x is equal to 1 by 25. So we will write this equation in terms x in terms of p, right? So they given 3px is equal to 2, but you can write x is equal to 2 by 3p, right? Now we got the values of x. X is equal to 2 and x is equal to 1 by 25. So we'll take x is equal to 2 and x is equal to 25, 1 by 25. So substitute these values. 2 by 3p is equal to 2. From this you can write p is equal to 1 by 3. Right. Now here x is equal to 2 by 3p. 2 by 3p is equal to 1 by 25. Correct. Now p is equal to 50 by 3. P is equal to 50 by 3. So this is 1 by 3, this is 50 by 3. What is the addition? The addition 50 by 3 plus 1 by 3 is 51 by 3. 51 by 3, that is equal to 17. That is they are asking. First option is the right answer. Sum of all possible values of p. There are two possible values of p whose sum is 51 by 3. If you cancel them, right, if you when you cancel the common factor between the two numbers, then you will get 17 as the answer. Right? I hope you understood this. Now we'll see the next one. So we'll see more than one correct answer type questions. More than one correct answer type questions. This is the question. So here they are given quadratic equations. Two quadratic equations are given. Alpha comma beta are the roots of ax square minus bx plus c equal to 0, and gamma comma delta are the roots of px square minus qx plus r equal to 0. Then which of the following statements is or true or false, or false? Which of the following statements are false? So this is more than one correct answer type. So A, only single A may be correct. Okay, only one option may be correct, or two options may be correct, or three options may be correct, or all are correct. So there may be more than one correct answer type. Right. Now I'll see the information given in options. If alpha comma beta comma gamma comma delta are in AP, then the common difference is, if alpha beta gamma delta are in GP, then the common ratio is, if alpha beta gamma delta are in AP, then the common difference is. You can observe here carefully, there are four options are given, and two options, right, are contradiction, right? So there may be only two are correct or two are false, right? Now we'll see. Now we'll see actual solution. How many are correct? We'll see. So they given that alpha beta are the roots of this equation, and they given here alpha beta gamma delta are in AP, right? Now I'll take the values, take the roots in such a way that they are in AP, right? So four terms are in AP. How can you take? Four terms are in AP. You can take whenever the first term is A and the common difference is D, then the four terms can be taken as A plus D, A plus 2D, A plus 3D, right? So these are the four terms. This is alpha, this is beta, this is gamma, this is delta. So four roots are in AP, first option, four roots are in AP, right? Now coming to the question, what they given, ax square, alpha beta are the roots of ax square minus bx plus c equal to 0, right? So if alpha comma beta are the roots, if alpha comma beta are the roots of ax square minus bx plus c equal to 0, then we can write the sum of the roots and product of the roots. What is the sum of the roots? Sum of the roots. Sum of the roots. Sum of the roots is alpha plus beta. That is equal to minus b by a. Actually here minus is there already, so it is b by a, right? Similarly, we will find product of the roots. Product of the roots. So what is the product of the roots? C by a. That is product of the roots is denoted by alpha beta, and it is defined as constant term divided by x square term. So c by a, right? So similarly, we can write the same expressions for the next equation, quadratic equation, right? What they given equation? If gamma comma delta are the roots of the quadratic equation px square minus qx plus r equal to 0, right? So this is only they given px square minus qx plus r is equal to 0. Now we will write the same expression, sum of the roots and product of the roots for this equation. What is the sum of the roots? The sum of the roots is, I will write directly here, this is gamma plus delta. So we have to write gamma plus delta is equal to Q by P, right? And gamma into delta, product of the roots, is constant term divided by coefficient of x square, that is P. So R by P, right? Constant term by coefficient of x square. So R by P. So we got the values, right? We got the values. Right? So these values, now first option, from the first option, we taken already alpha is equal to A, beta is equal to A plus D, gamma is equal to A plus 2D, delta is equal to A plus 3D, right? Because they told that alpha, beta, gamma, delta are in AP. Now we will see the relation. What they given here? Alpha plus beta. That means what? A plus D is equal to B by A. We can write that A plus B. A plus D. A plus D is equal to B by A. Right? Now from this, what you can write here? Gamma plus delta is Q by P. Gamma plus delta Q by P. What is gamma plus delta here? A plus 2D plus A plus 3D. A plus 2D plus A plus 3D. That is equal to Q by P. Right? Q by P, correct? Now we will solve these two equations to get D. So how can we solve this? First of all, simplify the equations. So I am simplifying these two equations. 2A plus D is equal to B by A, and this simplification is 2A plus 5D is equal to Q by P. Now subtract them. Subtract. This is, let it be second equation, and this is, let it first equation, right? So 2 minus 1. We will do 2 minus 1. What you will get? 2A gets cancelled. 5D minus 4D, 5D minus D is 4D. And this is equal to Q by P minus B by A. Now D is equal to, take LCM. What you will get? AQ minus BP by AP. So here 4 is there. This 4 will come to denominator. So this is the answer. AQ minus BP by 4AP. What is the common difference? The common difference is AQ minus BP by 4AP. AQ minus BP by 4AP. This is first option. But they are asking, that is the correct one. But they are asking false one. Right? False means not true. So corresponding to this, you can see here AP minus BQ by 4AP. What is the difference here? Q and P are interchanged. So option C is the right answer. Right answer means that is false. Right? A is the correct one. A is the, right, understood. A is the statement is correct. That is the common difference. But they are asking here which of the following statements are false. So at that time C is the option, required answer. Now we'll see the GP. So whenever alpha, beta, gamma, delta are in GP, right? Whenever alpha, beta, gamma, delta are in GP, alpha, beta, gamma, delta are in GP, right? This is they given. So if you take first term is A and the common ratio is R, then the four terms can be taken as AR square, AR power 3. These are the four terms corresponding to alpha, beta, gamma, delta respectively. Right. Now what they given here? What we have to find? Common ratio. Common ratio. How can you find the common ratio? You can see here the relation between the roots. Right. Product of the roots is C by A. Here product of the roots is R by P. Right. We will use that concept to find the common ratio. So alpha, beta is C by A. What is alpha, beta here? You can see these two are alpha, beta. Alpha is A. So alpha, beta is C by A. And another one is gamma, delta is R by P. Right. Now what is alpha? We consider A. And what is beta? AR. So A times of AR is equal to C by A. And this is AR square times AR power 3 is equal to R by P. Right. So this is A square R is equal to C by A, and here it is A square R power 5 is equal to R by P. Right. See, here you may get confused with this R and this R, right? So that's why we will consider the numbers. We will consider the numbers like this. So this is, we'll replace this. We'll replace because you may get confused, right? Now we will see this. Now we can see. I am taking the numbers AR square, AR cube, right? So this one is A into AR, this is AR square, this is AR cube, right? Now we need to find A square. Here it is A square R, here it is A square R power 5. Now what we have to do? Find a capital R, right? So find capital R value. How can you find capital R value? By dividing this by this, right? Dividing this by this, what you will get? You can see here, A square R power 5 divided by this. So when I am dividing, let it be this equation is third one, right? And this equation is fourth one. Now what you have to do? Third by fourth. I am writing third by fourth. So what is this? A square R power 5, A square R power 5 divided by A square R is equal to R by P divided by C by A, right? So what we left? Here A square gets cancelled. We left with R power 4 on the left hand side. We left with R power 4. We left with R power 4 on the left hand side. On the right hand side, AR by PC, AR by PC, AR by CP. You can write AR by CP. Now what is R? R is equal to AR by CP whole power 1 by 4. So this is the common ratio. AR by CP whole power 1 by 4. AR by CP whole power 1 by 4. That is the correct one, right? But we require the false one. So what is the false? So option D is the false because they given AP by CR whole power 4. Actual answer is AR by CP whole power 4, right? I hope you understood this. Now I'll see the next one. What is they given here? Plane. So this question is based on the concept of 3D planes, right? Planes and lines. So what is the plane equation? They given x minus 2y plus 7z plus 21 is equal to 0. Then which of the following statements are true? So right now they are asking what are the true. So read the question properly because they will make you confused by giving these statements. So we won't read. Generally students won't read properly. So due to this they will get the negative marking instead of getting positive marking, right? So you will lose your marks. So please concentrate, read the problem carefully, right? Now I'll see the question. So they given plane equation and they given 4 options here. The plane P contains the line. And the second one in plane, the plane P contains the point. This is plane, P-L-A-N-E. The plane P is perpendicular to the line, right? The plane P is parallel to the plane. So they given 4 options. We will study this now. So first of all, what is the plane? The plane you can take, it's like this. So this is the part of the plane. Plane is infinite in space, right? Infinite in space. I am taking the part of the plane. Now this plane, every plane is associated with the normal. Every plane is associated with the normal and it is perpendicular to the plane. So that means it will come like this. This is the normal. What is this? This is the normal, right? Whenever they given plane equation, AX plus BY plus CZ plus D is equal to 0 or equal to 0, whatever it is. Whenever they given plane equation like this, where A, B, C or means X, Y, Z coefficients, the coefficients of X, Y, Z are the direction ratios of the normal to the plane. So what are the direction ratios of the normal to the plane? This is the normal, then this is the direction ratios, DRs of normal. DRs of normal to the DRs of normal to the plane. So every plane is associated with the normal, right? Now we will see another information. Whenever the line lies in the plane or plane contains the line. Both are same. Line lies in the plane or plane contains the line means the line is, for example, is like this. This is the line. Line also infinite. It can be extended infinite up to infinity on either side. So this is the part of the line. Now you can see if this line lies on this plane, at that time it should satisfy the two conditions. What is that? The condition is whatever the point, every line x minus x1 by a, the line equation in the Cartesian form, x minus x1 by a, y minus y1 by b, z minus z1 by c. So this is the Cartesian form of the line equation, 3D line equation, right? So here you can observe that there are two things. One is the point x1, y1, z1. Another one is the direction ratios of the line, right? So every line has these 2 points, right? Information. x1, y1, z1 means the point lies on the line, right? And every line is associated with direction ratios, right? It's like a slope in the 2D geometry. Every line must have the point, right? And it has the slope in 2D geometry. Similarly, in 3D geometry, it's associated with these two things, x1, y1, z1, some point on the plane, a line, and the direction ratios. Now this is direction ratios are A, B, C. We will take like this. Now we can observe that this line lies on the plane. Whenever the line lies on the plane, every point on the line must lie on the plane. That means if any point x1, y1, z1, that point must satisfy the plane equation, right? Now we can see another one. Here the line lies on the plane. Whenever the line lies on the plane, this normal to the plane, that normal is perpendicular to the every line which lies in the plane. So you remember this point. So this line is perpendicular to this line also. Normal is a line. That line is perpendicular to this line also, right? So whenever the two lines are perpendicular, for example, we will take x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. Another line is taken like this, x minus x1 by a2, x minus x2, we can take x2, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. Whenever they are given the line is like that, at that time the condition is if whenever the two lines are perpendicular, a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So that condition you must remember, right? Now we will see whenever the two lines are parallel, so I will write this in the next page. You can see here x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. This is equal to lambda. X minus x2 by a2, y minus y2 by b2, z minus z2 by c2 is equal to mu. So these are the two lines in the plane. If two lines are perpendicular, right? So this is let it be 1 and this is let it be 2 equations. If one is perpendicular to 2, this is perpendicular symbol. One is perpendicular to 2, then the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Whenever the two lines are perpendicular to each other, right? Now whenever the two lines are parallel to each other, parallel symbol is this. Whenever the two lines are parallel to each other, then the direction ratios must be in the same ratio. That means a1 by a2 equal to b1 by b2 equal to c1 by c2. Equal to must be in some ratio. Clear? So you must remember these points in order to solve this problem, right? So whenever the problem is given, so you have to study the concept behind the question. What they are asking exactly. Now you can see what they are given here. Plane is given. Every plane is associated with the normal. So there are direction ratios of the normal is, direction ratios of this normal is 1 minus 2, 7. Direction ratios of this normal is 1 minus 2, 7. Right. Now we can apply here directly. They given the plane P contains the point. Whenever the plane contains the point or point lies in the point must satisfy this equation. Must satisfy the equation, plane equation. Directly substitute here. What is they given? X 0 minus 2 into 7 minus 14. This is minus 7. So minus 14 minus 7 is minus 21 plus 21. immediately they given plus 21 immediately, right? So minus 21 plus 21 is 0. So obviously this point lies on this, the plane, lies on the plane, right? Understood? Next one. So this is true, right? This is clearly visible by substituting just. No need to do calculations because of less time is given in the JEE Advanced exam. So we need to do fast by doing like this. Now we'll see the next any one option. You can see the A option. The plane P contains the line. So already I told you, whenever the line lies on the plane or plane contains the line. So two conditions must be satisfied. What is that? The point x1, y1, z1. The point must satisfy the plane, and the minus 3, 2, 1. That is the ratios of the line and the ratios of the plane. So whenever the line lies on the plane, so normal is perpendicular to the line. Normal is perpendicular to the line. So whenever the two lines are perpendicular, we'll see this here. So what is the given here? X minus 2y plus 7z plus 21. Right, we will write here. X minus 2y plus 7z, right, plus 21 is equal to 0. This is the plane equation. And what is the given here? X plus 1 by minus 3, y minus 3 by 2. Right, x plus 1 by minus 3, y minus 3 by 2. Right. And the third one is, what are they given here? Z plus 2 by 1. Z plus 2 by 1. Right. Z plus 2 by 1. So this is the line equation is given. Now this is a line equation. Already I told you. So if the line, this one, you can see this is the plane and this is the line. So every line, every plane is associated with some normal. So if any line lies on the plane, that normal is perpendicular to the line because it is perpendicular to the plane, right? So whenever it is perpendicular to the plane, this normal is also perpendicular to any of the line present in the, which lies in the plane, right? So you can see here, so direction ratios of this and the direction ratios of this, sum of the products of the both direction ratios, right? So if this is, what is the direction ratios here? Minus 3 to 1. So the direction ratios of this line is minus 3 to 1. What is the direction ratios of the plane? 1, minus 2, 7. Right. So these are the two direction ratios. Now what is the property? What is the condition whenever the two lines are perpendicular? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. That is 1 into minus 3, minus 2 into plus 2, minus 4, plus 7 into 1, 7. So this is clearly 0. Yes, these two lines are perpendicular because the condition is satisfied. Now we will see the point of the line. What is the point of the line? Minus 1. This is 3. Whenever this term equated to 0, numerator equated to 0, you will get the point x coordinate, y coordinate, z coordinate like that, right? So every numerator must be equated to 0. So 3, here it is minus 2. So this is the point on the line. This is the point on the line. The point, whenever the line lies on the plane, the point, every point on the line must lies on the plane. So it should satisfy the equation of the plane. So this point should satisfy the equation of the plane. That is, what is that? 1 into, minus 6 plus minus 14 plus 21. So here it is what? This is minus 7 minus 14 minus 21. Minus 21 plus 21 is 0. So the point satisfied by the plane. The point satisfied by the plane. That means what? This point satisfying the plane means this line. So this condition also satisfied. So we can say that this line lies in the plane, right? So first option is correct. First option is correct. Now we'll see the third option. The plane P is perpendicular to the line. It's very simple. Whenever the plane P is perpendicular to the line means, right, a line is perpendicular to the plane. Line is perpendicular to the plane means, so whenever the plane is like this, and line is perpendicular to the plane, already we know that every normal is perpendicular to the plane. So that means this normal and the given line and this normal, right, both are parallel to each other. Whenever they are parallel to each other, already I told you the ratios, their direction ratios are in the common ratio, the direction ratios, right? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So what is the direction ratios of the normal? The direction ratios of the normal is 1 minus 2, 7, and the direction ratios of the line is 1 minus 2, 7. Yes, they are in the common ratio, they are in the same ratio, 1, 1, 1, right? Understood? So this is also correct. So this line is perpendicular to the plane. Now we'll see the third one, fourth one. The plane P is parallel to the plane. Plane P is this plane is parallel to this plane. Right, if two planes are parallel to each other, if two planes are parallel to each other, they have the same normal, common normal, right? For example, ceiling and floor, there are two planes, ceiling and floor. So they have the same normal. This means they have the direction ratios of the normal to the plane are same, 1 minus 2, or they must be in the common ratio. They must be in the common ratio. So here 1 minus 2, 7, 1 minus 2, 7, yes. So remember one thing, two parallel planes differ with only constant term. Two parallel planes differ with only constant term. You must remember that point. Right, here you can see plus 21 is there, here plus 21 is not there. So they are parallel to each other because of their x coefficients and y coefficients and z coefficients are same or are in the same ratio. You can say like that also, right? So this is also correct, right? Now we'll see the next question. This one, they give an equation f of x equal to x square times e power 1 by x, 1 minus x square, and it is defined from minus 1 to 1 to r, where the domain is minus 1 comma 1, open interval, and the codomain is r. Be continuous function such that this is the function. They are asking which of the following statements are true. So read the question properly. True, right? Increasing, decreasing, like this, right? So we'll see solution to this. First of all, to find increasing or decreasing, with the help of differentiation, we can say whether the function is decreasing or increasing at particular interval, right? And we will see these two also. After drawing the curve, so we will analyze the curve, then we can say whether this equation has solution or not, right? We'll see the first derivative of this. What is the f of x? F of x is x square into e power 1 by 1 minus x square, right? And they given x value minus 1 to 1. So when you do squaring on both sides, you will get like this. When you multiplying minus on both sides, this inequality will be reversed, right? Minus x square, this is less than 0. Add 1 to this, you will get 0, 1 minus x square less than. So the range of this 1 minus x square is lying in the interval 0 to 1, right? Understood? Now we will see here. So here they given f of x. What is f dash of x? What is f dash of x? F dash of x, this is UV rule, right? You can apply the rule of UV. What is that? U into V dash plus V into U dash, right? But again it is composite function. V as a composite function, right? So we have to differentiate chain rule. We have to apply chain rule for V also, right? After applying UV rule. So what is that? X square, right, as it is, and a differentiation of this is e power 1 by 1 minus x square, right? E power x differentiation, e power x into differentiation of this one is minus 1 by 1 minus x square whole square, right? 1 by x differentiation is minus 1 by x square. Now minus x square, 1 minus x square differentiation, 1 minus x square differentiation is 0 minus 2x, right? So this is u into v dash. Now v into u dash, what is v? E power 1 by 1 minus x square, that is v. U dash is x square differentiation is 2x, right? 2x. So this is the differentiation. Differentiation is simple. Right now we have to find where the function is increasing, decreasing with the help of this. How can you find? Find the values of x where the f dash of x is 0. So how can you find? By equating these terms to 0, you will get the values of x and place that values on the real number line and put positive, negative like that. So we can identify easily, right? Now we'll simplify this. What is that? X square. What is the common thing? X is common. E power 1 by 1 minus x square is common, right? Now we will take the common thing, that is x common, right? X is common, 2x also common, na? 2x is common, 2x is common, into e power 1 by 1 minus x square also common. So what is left inside the bracket? X square, this 2x is taken out, and this e power 1 by 1 minus x square is taken out. X square, this one, x square minus into minus plus x square by 1 minus x square whole square. 1 minus x square whole square, right? Now here only 1 is left. Only 1 is left. Now we can see clearly here, this one is perfect square in the numerator and denominator. So this is positive. So this is also positive. So this is positive. For any value of x, this is positive. Because of 1 minus x square value is lie in the interval 0 to 1. Because x lie in the interval minus 1 to 1. Right? So this is positive for any value of x. Right? Now, we left with this only. So whenever equated to 0, this can't be 0. So this should be 0. 2x, so this can't be 0 because of it is exponential function. So this can't be 0. So this should be 0, right? 2x is equal to 0. We got x is equal to 0. So what is the root we got? X is equal to 0. Place the value on the real number line to check where the function is increasing or decreasing, right? So put 0 here, put positive, negative. Now, whenever this is the sign of f dash of x. What is this? Sign of f dash of x. So sign of f dash of x. So when we are moving from left to right, you can see here the sign of f dash of x is changing from negative to positive. Negative to positive means the graph of f of x. The graph of f of x. Graph of f of x is like this. That means it has minimum at x is equal to 0. The graph of f of x has minimum at x is equal to 0. So this is the approximate graph of the function f of x. With the help of the differentiation, with the help of the first differentiation, we can find this. This is called first derivative test. Now we will see, we will draw the graph of the function, right? So this is the coordinate axis. Now I am drawing the graph of the function in the interval minus 1 to 1. So why I am drawing in the interval minus 1 to 1? Because given the domain is minus 1, 1. So we need to keep the graph in that region only, right? So under codomain is R. Now I am drawing the two lines like this here. Now I am drawing, this is 1, this is minus 1. Now I am drawing the graph of the function by substituting x is equal to 0 here. When I am substituting x is equal to 0, you will get 0. Clear? Whenever x is extending to 1, at exactly 1, this is not defined. This function is not defined at x is equal to 1. This e power 1 by 1 minus x square is not defined. Because if an x is equal to 1, this becomes 0. E power 1 by 0 is infinity. E power infinity is infinity. So e power infinity is infinity whenever x is equal to 1. So it is not defined at x is equal to 1. But we will take the limit whenever x tending to 1 on the left hand side. Whenever x tending to 1 on the left hand side, x tending to minus 1 on the right hand side. Right? So we will see that. So here I am drawing the graph of e power 1 by 1 minus x square. So whenever x is equal to 1, if x is equal to 1, this is not defined, but x tending to 1 minus this function tending to, this is let it be g of x. So this g of x tending to infinity. So whenever x tending to 1 minus 1 plus, for that value also g of x tending to infinity. Correct? Now I will see this. At x equal to 0, 0. At x equal to 0, 0. Because of they given x square into e power 1 by 1 minus x square. So 0. Now x tending to 1 and it has minimum value. So the graph must be minimum, means the graph will be like this, right? So already we saw here. Now whenever x tending to 1 minus, graph tending to infinity, right? So the graph will be like this. This is the graph, and here also in this side, this is the graph. So this is the graph of the function. This is the graph of the function in the interval minus 1 to 1. Now we almost done. Now I'll see here what they given. It is decreasing in the interval minus 1 to 0. Decreasing in the interval minus 1 to 0. Yes, correct. And increasing in the interval 0 to 1. Clear from the graph? Now we'll see this. F of x is equal to, so it is decreasing in the interval minus 1 to 1, 0, correct? Increasing in the interval 0 to 1, correct? f of x is equal to 1 has two solutions. F of x is equal to 1 has no solution. Now I'll draw the graph. So x is equal to 1, y is equal to 1 means somewhere else here, right? So this is the y is equal to 1. This is a line y is equal to 1. So f of x is equal to 1. This is f of x. F of x is x square e power 1 by 1 minus x square. And that is equal to 1. So that means we have to find number of intersection points between the two graphs. That is y is equal to 1 and y is equal to x square into y is equal to x square. What they given here? F of x is this and 1 is given on the right hand side of the equality sign. So we need to consider the two equations. One is y is equal to this and y is equal to 1. Another one. So we need to draw these two graphs in the same coordinate plane. Identify how many number of intersection points are there. That many number of intersection points is equal to the number of solutions. So how many number of intersection points are there? Clearly there are two solutions are there. Two intersection points are there. So the answer is it has two solutions, not no solution. It has two solutions. Understood? So answer is ABC. Clear? Now I'll see the next question. I hope you understood this. A circle of radius 4 centimeter is inscribed in a triangle ABC which touches the sides BC at D. If BD equal to 6, CD equal to 8 centimeter, then which of the following statements are true? Right. Then the perimeter of the triangle, area of the triangle, triangle ABC is acute angle, obtuse angle, like this, right? We will try to draw the graph of this function. After that we will find the values of missing values, right? So first of all, what is they given? They given a triangle is given and in this circle is inscribed. Circle is inscribed in a triangle. Circle is inscribed in a triangle, right? Now we know the property, say circle. So these two are tangents from here to here. These are the two tangents are equal in length. Equal in length, right? So these two tangents are equal in length. Right? Now we will see this value is let it be A and this is taken as B. This is taken as C. Now this intersection point is means touching point with the circle. So BC side touching the circle at D and this is E and this is F. So we will take like this. Now we must understand one thing. So this length, the length must be equal, right? So this length they given that this is 6 and this is 8. So if this is 6 and 8, then obviously this length also 6 and this length also 8, right? We'll take this length also, this is 6 and this is 8 because these two are the tangents. So I'll draw the another circle to understand this. So if you draw the two circles like this, one circle, two tangents to the circle from the external point. So the tangent length, the length of the tangent means from this point to wherever it is touching the circle, right? That length, this length is called length of the tangents. So this length must be equal. These two lengths must be equal. And when you join this with the center of the circle, this point join this center of the circle. So this angle and this angle also equal, right? Also equal. Clear? So you must understand this information. So when you draw the two tangents from the external point to the circle, the length of the tangents are equal and the two tangents obtaining the same angle at the center, right? Two tangents obtaining the same angle at the center, right? Now we'll see here, this one, these two angles are same. Now we can see here, this one, we will use this concept here. This is 6, then this must be 6. This is 8, this must be 8. Now we'll see here, this must be x. We will take it is as x. Now what they given that the radius of the circle is 4 units. So this must be 4 units and this must be 4 units and this must be 4 units. And one more thing, here you can see, when the line segment joining center of the circle to the tangent is always perpendicular to the tangent. The line segment joining, that is radius, the line segment joining center of the circle to the tangent, means center of the circle to the tangent or point of contact of the tangent is perpendicular to the tangent. So this is perpendicular to the tangent. So this is perpendicular and this is also perpendicular. when you join like this is perpendicular, right? So this is also perpendicular. Now what I am doing here, I am finding this one. You can see here I am joining this. Right? So this angle, if this angle is B, then this angle must be B by 2. So this angle must be B by 2 and this angle must be C by 2. Right? So now what we can find here? With the help of the trigonometric ratios, we can find the tan B by 2 value. What is tan B by 2? What is the value of tan B by 2? What is the value of tan B by 2? The tan B by 2 value is opposite by adjacent, 4 by 6. 4 by 6, that is 2 by 3. Similarly, we will find the value of tan C by 2. What is the value of tan C by 2? Opposite by adjacent, 4 by 8, that is equal to 1 by 2. Now we will find the tan of B plus C by 2, right? So using the formula tan of A plus B, tan of B by 2 plus C by 2. So what is the value? Tan B by 2 plus tan C by 2 divided by 1 minus tan B by 2 into tan C by 2. Now tan B by 2 value already we calculated here, 2 by 3, and tan C by 2 value 1 by 2. 2 by 3, 1 by 2. So this is 2 by 3 and this is 1 by 2. By 1 minus 2 by 3 into 1 by 2. Simplify this, you will get 2 to the 4 plus 3, 7 by 6 divided by, this is 5 minus 2, 3 by 6. So 6 gets cancelled, we left with 7 by 3. Correct? This is 6 minus 2, 4. This must be 4. So this must be 4, 7 by 4, right? So 7 by 4 is the answer. So now this is tan of B plus C by 2. Tan of B plus C by 2. B plus C by 2. So what you can write here? Because this is the question based on triangle. Sum of the angles in the triangle is 180 degree. So whenever 180 degree, whenever divided by 2, right? What you will get? So A plus B plus C, sum of the angles is equal to pi. So when you divide by 2, you will get A plus B, A by 2 plus B plus C by 2 is equal to pi by 2. We can shift this A by 2 to that side. So you will get B plus C by 2 value. So B plus C by 2 can be written as pi by 2 minus A by 2. That is equal to 7 by 4. So what is tan of 90 minus theta? Is cot theta. So cot A by 2. What is the value? Cot A by 2 is equal to 7 by 4. Cot A by 2 is equal to 7 by 4. Right? Cot A by 2 is equal to 7 by 4. Tan A by 2 is equal to 4 by 7. Tan A by 2 is equal to 4 by 7. So now we have to calculate the tan A by 2 value. Tan A by 2 value. Right? So now I am drawing this, joining this. When I am joining this, you can see here from here to here. I am joining this. So you can see this triangle. Let it be the center is O. So triangle is AOE. This is a right angle triangle. So this total angle is A, then this angle must be A by 2. So tan A by 2 is equal to opposite by adjacent 4 by x. So tan A by 2 is equal to 4 by x. Tan A by 2 is equal to 4 by x and is equal to 4 by 7. We can write x is equal to 7. We got the x value, right? So after getting x value, it's very easy to find the remaining values. Now you can see here, just I am drawing the triangle. So this length, this is 6, this is 6, this is 8, this is 8, and this is 7, this is 7, right? This is the given information. Now they are asking perimeter. So what is the perimeter? Sum of all the surrounding lengths, that is called perimeter. So 7 plus 7, 14, 6 plus 6, 12, 8 plus 8, 16, right? You can write like that. So what is the answer here? You can see 8 plus 6, 14, 8 plus 6, 14, right? 14 to 14, 28 plus 14. This is how much? 42, right? So answer is 42. Perimeter is 42. First option is right. The perimeter of the triangle ABC is 42 centimeter. Now area of the triangle is, how can you find the area? How can you find the area? You can see this triangle here. See here, this triangle consisting of three smaller triangles. This triangle, big triangle, have three smaller triangles. You can see here BOC, one triangle, AOC another triangle, AOB another triangle. So the areas, the sum of areas of all these triangles is equal to the area of the big triangle. So area of AOB, because this line is perpendicular to the base, so this line also perpendicular to the base, right? So we will use that concept here to find the area of the triangle. Area of AOB plus area of BOC plus area of COA. So we will take that. So area of triangle ABC equal to area of area of OAB, right, plus area of OBC plus area of OCA. You can take this, where O is the center of the circle. Now we can see here. So what is the area of OAB? OAB, you can take this. So this is the right angle. So half into base into height. Whenever it is right angle, half, this is height and this is base. So it is already, we got 7. 7 plus 6, 13. Half into 13 into 4. Half into 14 into 4. Half into 15 into 4. Right. So what is the common thing? Half into 4 common, 13 plus 14 plus 15. So answer is, so half into 4 common, that is into 13 plus 14 plus 15. So what is the answer? This is 2 times of, this is 13 plus 14 plus 15. This is 13 plus 14 is 27 plus 15, that is equal to, so 2 into, this is 2, 42. 42 into 2, 84. 84 square units are centimeter square. Right, centimeter square is the answer. So 84 is the answer. B is the right answer. Similarly, we will see the third one. The triangle is ABC, acute angle or obtuse angle. So either one of these will be correct. Both cannot happen at the same time in a triangle. So now we will see that how to find. So already we got the value tan A by 2 is 4 by 7. Tan A by 2 is 4 by 7. So tan A by 2 is 4 by 7. Then 4 by 7. Then we can find the value of tan A. What is tan A? 2 tan A by 2. 2 tan A by 2 by 1 minus tan square A by 2. Right. So what is 2 tan A by 2? 2 into 4 by 7. 2 into 4 by 7. 1 minus 16 by 49. So simplify this. What you will get? This is 8. 8 into 7, 56. Divided by, this is 9 minus 6, 3. 4 minus 1, 3. 33. So 56 by 33 is the positive value. Right. So this is the positive value. Tan A value is positive. So whenever it is positive, the angle A lies in the first quadrant or in the third quadrant. But in a triangle, the angle should not exceed more than 180. Right? Should not exceed 180. So that's why this angle must be lie in the first quadrant. So whenever tan A is positive, this is possible in 2 possibilities are there. It is lies in the first quadrant or in the third quadrant. But in a triangle, angle cannot exceed, right? Cannot greater than, it's not greater than 180. So that's why A lies in the first quadrant, so it is less than 90. Angle A is less than 90. Similarly, we can calculate the tan B by 2 value, right? Tan B value. So we will get that also as acute angle. So finally, we will get acute angle triangle. Acute angle triangle, right? C is the right answer for this question. So we will do in the same way, right? Now we will see the next one. This question, they are asked, in a triangle ABC, tan A and tan B satisfying the inequality, they give an inequality expression, root 3x square minus 4x plus root 3 less than 0, then which of the following expressions are true? Right. So this is also easy question on more than one correct answer type. Now see this, factorize, root 3x square minus 4x plus root 3. So root 3x square minus 4x plus root 3 less than 0. Right? So what is the factors? So same method, splitting the middle term, root 3 given as the x square coefficient or constant term. The product is 3. Product is 3. The product is must be 3 and the addition of those two numbers must be minus 4. So what are the possibilities to split the middle term? What are the possibilities? Here A is equal to minus 3, B is equal to minus 1. You can take like this. You can take in opposite way also, right? So now factorize this with the help of this. Minus, this is what? Minus 3 minus 1. Minus 3 minus 1. So I am splitting the middle term. I am splitting the middle term 3x minus x. Minus 3x minus x plus root 3 less than 0. Right. Now, what is the common thing between these two terms? Root 3x common. X minus root 3. What is the common thing between these two terms? Minus 1 common. X minus root 3. So, what is the common thing again? X minus root 3. And this is root 3x minus 1 less than 0. Now, equate to find where this expression is negative, right? For what values of x this expression is true. To find that, we need to equate each of these factor to 0, place that values on the real number line in the increasing order, put positive, negative like that. So this is called wavy curve method. So equate each of these factor to 0, you will get root 3 comma 1 by root 3. I am placing these values on the real number line. 1 by root 3 and root 3. Now put positive, negative, positive, right? So this is usually we are doing in the concept of inequalities. So with the help of inequalities, we can solve this. Now, what they are asking, for what values of x this expression is negative. So when it is negative, for the values x belongs to 1 by root 3 to root 3, the given expression is negative, right? Now, so 1 by root 3, what is the answer? Less than x less than root 3. This is the given, for these values of x, the given expression is true. Now, what you have to do? So x is, the values of x is tan A and tan B, because they given tan A and tan B are satisfying this, tan A and tan B satisfying this inequality, right? So tan A and tan B, I am writing tan A and tan B in place of x. This is tan A less than root 3. Similarly, 1 by root 3 tan B less than root 3, right? Now what we will do? So whenever this is tan, we have to find the values of A from this. What is the values of A for both? This is 1 by root 3. 1 by root 3 means tan 30 degree, pi by 6. So pi by 6. So tan is increasing function in the first quadrant, right? In the first quadrant, it is increasing function. It is increasing function in the interval pi by 6 means 30 to 60, right? So that's why it is pi by 6 less than A less than pi by 6 less than A less than, this is pi by 3. Similarly here, pi by 6 less than B less than pi by 3, right? Understood? Now we can see here, we will add these two. Whenever we are adding this, we will get pi by 3 less than A plus B less than 2 pi by 3. See, whenever they have the same inequality, if two inequalities containing the same inequality sign, then we can add them. We can add them like this, right? Now we can see it's lying in the interval pi by 3 to 2 pi by 3. Now I am applying, so this is in a triangle ABC. So we can apply pi by 3. We will apply this. A plus B plus C is equal to pi. So what you can write, A plus B is equal to pi minus C. So we will apply this. We can write this. So pi minus C less than 2 pi by 3. Now apply cos. Apply cos to each of these terms, right? So whenever applying cos, cos is decreasing function. Cos is decreasing function. That's why. So whenever applying cos, so this inequality will be reverse. Inequality will be reverse. So what is that? Cos pi by 3 greater than cos of pi minus C greater than cos 2 pi by 3. Inequality will be reverse whenever function is decreasing function. Now cos pi by 3 is what? Cos 60. Cos 60 1 by 2 greater than cos pi minus C is minus cos C. This is cos 2 pi by 3 is 120. It is minus 1 by 2. Cos 120 is minus 1 by 2. Now we will multiply with minus. We will multiply with minus. So the same inequality will come without negative to the cos. right, like this, minus 1 by 2 to 1 by 2. Now, what is cos C? Sorry, this is cos C. What is cos C? Cos C. Cos C. So, it's a right angle triangle, sorry, a triangle whose vertices are ABC, whose sides BC length is A, CA length is B, AB length is C, right? So, this is usual meaning. We will take the sides of the triangle like this, right? Now, cos C. What is the cosine rule for cos C? Cosine rule is B square. C. After C, what will come? A, right? A square. So, this is C, cos C. Right. So, sum of the squares, adjacent one, sum of the squares of the adjacent sides minus square of the opposite side by 2ab. So, that is a square plus b square minus c square by 2ab less than half. Right. Now, we will see. Right. Now, simplify this. Simplify this expression. 2 gets cancelled on both sides, 3 sides. Now, we left with AB, right? A and B are positive. So, product is positive. We can cross multiply directly. Whenever the denominator is positive or negative, we can cross multiply directly, right? So, we will cross multiply. What will left? We will get minus AB less than A square plus B square minus C square less than AB, right? So, if you split this, you will get A square plus B square plus AB greater than C square, right? This is one. This is one. Another one, A square plus B square minus AB less than C square. Another one. So, minus AB less than C square plus AB greater than C square. So, this first option and fourth option are correct. Correct? Now, we'll see the next one. This question is based on complex numbers, more than one correct answer type, right? Now, we will see, we will study what is they given first. What they given here? Z1, Z2, Z3 be 3 distinct complex numbers satisfying their magnitudes are 1. Magnitudes are 1, right? Then which of the following are true? They are given which of the following are true. So, argument of Z1 by Z2 is equal to pi by 2. Then argument of this is whenever mod Z greater than 1. Second option, mod of Z1 Z2 plus Z2 Z3 plus Z3 Z1 is equal to mod of Z1 plus Z2 plus Z3. Third one, imaginary part of Z1 plus Z2, Z2 plus Z3, Z3 plus Z1 by Z1 Z2 Z3 is equal to 0. And the fourth one, if modulus of Z1 minus Z2 equal to root 2 times of modulus of Z1 minus Z3 plus root 2 times of Z2 minus modulus of Z2 minus Z3, then real part of Z3 minus Z1 by Z3 minus Z2 is equal to 0. So, which of the following options are correct for the given information, right? Now, we will study this. So, what is the, so we will first draw the diagram. After that, we will solve all these things. What is the given? 3 complex numbers and their magnitudes are equal to 1. So, we will take the circle. We will take the circle like this, right? And magnitudes are 1. So, we will take the values like this. I am taking 1, another one is omega, another one is omega square. So, where z is equal to 1, omega square. So, z1, z2, z3. This is z1, this is z2, this is z3. I taken like this for the given information because whose length is 1. This is origin. This length is 1, right? This length is 1, this length is 1, this length is 1. So, magnitudes are 1 only. Magnitude means what? The distance from origin to the point. That is called magnitude. So, magnitudes are 1. So, we taken like that. Now, so what they given information right now? You can see here. Here, they given, we will take this one first, third option. We will take the third option. They given Z1 plus Z2, Z2 plus Z3, Z3 plus Z1. They are in product. Divided by Z1, Z2, Z3 are in product. Now, we need to, whether we have to check whether this is a complex number whose imaginary part is 0 or not, right? So, now we will solve this with the help of this. So, what is they given? Information C, option C. Z1 plus Z2, Z1 plus Z2, Z2 plus Z3, Z3 plus Z1. So this is the given. Z1 plus Z2, Z2 plus Z3, Z3 plus Z1 is given, divided by Z1, Z2, Z3. This is the given. So this is the complex number, right? We have to find whose imaginary part is 0 or not, right? So for that, I consider the numbers 1 omega omega square. We can take like that because they given the information whose magnitude is 1. Yes, whose magnitude is 1, right? So now I am substituting here. What is that? Z1 plus Z2, 1 plus omega. We have the two rules from this. What is that? 1 into omega square, that is omega cube is equal to 1. 1 plus omega square is equal to 0. So you must remember all these things, right? Now 1 plus omega, this is omega plus omega square. This is omega square plus 1 divided by, right? So don't confuse here. This one is separate. So divided by, right, Z1, Z2, Z3, that is 1 into omega square. So denominator part is 1 because of 1 into omega square is equal to omega cube, that is equal to 1, right? This one, 1 plus omega square plus 1, we'll write as it is, multiplying these two, and this one is minus 1 clearly. So minus 1, this part is minus 1. So that part I am taken outside. So I am multiplying this to 1 into omega square, 1 into 1, 1, omega into omega square, omega cube, omega into 1, omega, and the denominator is 1 already, right? So because 1 into omega square. So now we can see omega cube 1, this is 1, 2, omega square plus omega minus 1 from this, omega square plus omega minus 1, right? So this is minus 1. These two values become minus 1. Omega square and omega become minus 1. Minus 1 plus 1 gets cancelled. We left with omega cube. Omega cube is 1. So the value is minus 1 finally. The value of this complex number is minus 1 for the given information. So the complex number is minus 1. Whenever the complex number is minus 1, what is the argument? What is the argument of Z? Argument of Z. That means the point lies on the negative side. So this is minus 0 comma minus 1. This is 0 comma minus 1, right? So this point is 0 comma minus 1. So whose argument is minus pi by 2? So you can see clearly here what they given here. So this is the real number. This one is wrong. This one is wrong. This is not the point. This is not the point. This is the point. Minus 1 comma 0. This is the point. See clearly here, argument of Z is what? Argument of Z is pi. And what is that? Imaginary part of Z. What is the imaginary part of Z is? 0. Imaginary part of Z is 0. So Z is equal to minus 1. Minus 1 is purely real. There is no any imaginary quantity. So imaginary part is Z is 0. Clear? Understood? Now I'll see the next one. What is that? B option. B option. See, whichever is easy, that I am doing first. Right? So whichever is difficult, that you will do later. B option. Z1, it's very simple. They given, that is given modulus of Z1, Z2, Z2, Z3, Z3, Z1. Right. So I am taking a mod Z1, Z2, Z3 common from every number. Mod Z1, Z2, Z3 common from every term. So what is left? 1 by Z1 plus 1 by Z2 plus 1 by Z3 is left inside the bracket, inside the modulus. Now, so already they given the information mod Z is equal to 1. Mod Z1 is equal to 1, mod Z2 is equal to 1, like that, right? So mod Z1 square, when I am doing squaring, so this become Z1 bar is equal to 1. We can write like that, mod Z is equal to 1, then ZZ bar, mod Z square can be written as ZZ bar. So Z1 bar also 1. So Z1 bar is equal to 1 by Z1. So with the help of this information, right, so we can write here 1 by Z1 as 1 by Z1 was Z1 bar, this is Z2 bar, this is Z3 bar, right? So this one is mod Z1 into mod Z2 into mod Z3. You can write like this. This part is 1 because of every magnitude is 1. So this one with the help of the property mod Z1 plus Z2 whole bar is equal to, what is the property? Modulus of Z1 plus Z2 whole bar can be written as mod Z1 bar Z2 bar. So this is the property. So we will apply this property here. What is the property? So that is equal to, this is the property, right? Now we can see what you can write here, Z1 plus Z2 plus Z3 whole bar, and already we got here, what is the information? Mod Z1, you can see the another formula, mod Z is equal to mod Z bar. This is the formula, mod Z is equal to mod Z bar, right? So this value is also, this value is equal to modulus of Z1 plus Z2 plus Z3, clear? So Z1 plus Z2 plus Z3, understood? So this is already they given, this is, that is equal to this, correct? So this equal to this we got, correct? Now see the fourth one, D. If Z1 minus Z2 root 2 times of Z1 minus Z3 root 2 times of Z2 minus Z3, right? So I'm changing this, root 2, I'm dividing with root 2, right? Dividing with root 2, at that time mod Z1 minus Z2 by root 2, Z1 minus Z3 by 1, Z2 by Z3 by 1, like that I will get, right? So now I am writing that as this one, option C. I am doing option C. What is I am doing here? Z1 minus Z2 by root 2 is equal to Z2 minus Z3 by 1, Z3 minus Z1 by 1, right? Now you can observe carefully here, when I am equated to K, this is in the common ratio, right? This is the common ratio. So when I am equated to K, you will get this length, this magnitude is equal to root 2K, this magnitude is equal to K, this magnitude is equal to K. So what is that? So when you observe carefully, these three sides are the forming the right angle triangle, right angle at Z3, right? So this is Z1, this is Z2. Now we can see clearly here. So I am rotating like this, I am rotating Z1 to, so when I am rotating like this, Z1, so this is like this. So I am rotating like this, anti-clockwise rotation. So what is that you can write? So argument of when I am rotating like this one Z2 minus Z3 by Z1 minus Z3, right? This is the complex number. I am rotating like this. So Z1, this is Z3 Z1. So complex number joining from Z3 Z1, I am rotating like this. When I am rotating, this complex number come in the denominator and this complex number come in the numerator. So argument of this is pi by 2. This is pi by 2 because it is 90 degree here with the help of given information, because this is K and this is K, this is root 2K. They given here, right? So when you take root to that side, you will get these values. So you can see clearly this is the forming right angle triangle. The sides forming right angle triangle, right angle at Z3. Now I am rotating like this. So this is right angle triangle. So what is the angle? 90 degree. So argument of Z2 minus Z3 by Z1 minus Z3 is pi by 2. Right? Now what they are asking exactly now. So whenever argument is pi by 2, this complex number is imaginary, right? Imaginary. So what they are asking here. So the complex number is Z2 minus Z3. What they are asking here? Z3 minus Z1 by Z3 minus Z2. So we can rewrite this equation like this. What is that? Z1 minus Z3 by Z2 minus Z3. Z2 minus Z3. You can write like that. So this is the complex number we required. Z1 minus Z3. So but here it is in the opposite. It is in the numerator and denominator is in the opposite direction, right? We will convert into like that. So how can you do that? So argument of Z2 minus Z3. Z2 minus Z3 minus argument of Z1 minus Z3 is equal to pi by 2. So when I am multiplying with minus, what is happening? So argument of Z1 minus Z2, Z3 minus argument of Z2 minus Z3 is equal to minus pi by 2. So this can be modified like this. Argument of Z1 minus Z3 divided by Z2 minus Z3 is equal to minus pi by 2. So whenever it is minus pi by 2, this complex number is purely negative imaginary. Imaginary and it is purely negative imaginary. So negative number. So Z1 minus Z3, Z1 minus Z3, Z2 minus Z3 is purely negative imaginary. Negative imaginary. Right. That means what? Whose real part is 0? Whenever it is purely negative imaginary, then real part is 0, na? Clear? Now I'll say this. So fourth option also correct. Or D option also correct. Now I'll see the first option. What are they given here? Argument of Z1 by Z2 is pi by 2. Then argument of Z minus Z1 by Z minus Z2 greater than pi by 4 whenever mod Z greater than 1. So we'll see the diagram for this. Right. I'll draw the diagram for this. So what is the diagram? But here only we'll see the clearly. Here you can see. The diagram is given like this. You can see here. Okay. Here I will draw the diagram. You can see here. So this is the 2 points. Any 2 points Z1, Z2. And this is the center of the circle. What is given here? Argument of Z1 minus 0 by Z2 minus 0. This can be written like that. So Z1 minus 0 by Z2 minus 0 means, so this angle, right? The angle subtended by arc, the angle subtended by arc at the center is 90 degree. They given. Angle subtended by arc at the center is 90 degree. Now we have one theorem from the 10th class. The angle subtended by arc at the center is double the angle subtended by at a circumference of the circle. Double the angle subtended by the arc at the circumference of the circle. Right. The angle subtended by arc at the center is the double the angle subtended by it on the circumference of the circle, in the remaining part of the circumference of the circle. So this is the arc, this is a smaller arc. So this subtending in the remaining part of the circle. You can see I am drawing the like this. You can draw many triangles like this. So this angle must be pi by 4. This angle is pi by 4 because angle subtended by arc at the center is double the angle subtended by it in the remaining part of the circumference of the circle. Right? So with the help of this theorem we can solve this. So this is radius is, whenever radius mod z is what? Radius is 1. Whenever radius is 1, at that time the point lies on the circumference. Whenever radius is 1, whenever point on the lies on circumference, and argument of this is pi by 4. But here they are asking greater than pi by 4. So when it is possible? So you can see here, whenever I am increasing like this. For example, I am drawing the triangle like this. When I am drawing the triangle like this, right? So when I am drawing the triangle, you can see here, this angle is, whenever it is increasing, point is increasing, right? Angle is decreasing, angle should be decreasing. This is less than pi by 4. Clearly, this angle is less than pi by 4. Consequently, magnitude of z, right? Z magnitude is greater than 1, right? Greater than. So whenever the magnitude of z is greater than 1, the angle is reducing, not increasing. The angle is reduced. So this is given false. This one is false because whenever the magnitude is increasing greater than 1, whenever magnitude of z is greater than 1, the angle is less than pi by 4, not greater than pi by 4. So that one is wrong. Clear? Now I'll see the next one. So this question is based on applications of derivatives, increasing, decreasing, right? Using that concept we can solve this. So 5 by 13 whole power x or 12 by 13 whole power x minus 1 is given. Just to do the differentiation, it's done, right? So 5 by 13 whole power x plus 12 by 13 whole power x minus 1. This is the given function. So differentiate this. So what you will get? 5 by 13 whole power x, it is in the form of a power x into log a. So log 5 by 13 plus 12 by 13 whole power x into log 12 by 13. This is differentiation is 0, right? This is the differentiation. Now, we all know that log values, log function, log producing the negative values for the interval 0 to 1, right? This value is negative. This value is negative. This is negative. And this is also negative because this is less than 1. The value is less than 1. The log of that value is negative. So, you can observe here for the interval 0 to 1, the log producing negative values. So, negative, negative. So, obviously this is positive always. This is positive. So, this is positive, positive, negative, negative. So, this is positive. Right. So, positive and negative, negative. So, finally it will be negative. So, f dash of x is negative. That means what? F of x is decreasing function. F of x is decreasing function. Decreasing function. Right. For all x belongs to R. For all x belongs to R. Decreasing function. The given function is decreasing function. Right. Now we will see this. Decreasing function. Now we'll see what they given here. Whenever decreasing function means it will be like this, right? So now whenever x is equal to 0, you can see here, this become 1, this become 1. So 2 minus 1 is 1. F of 0 is 1. Now whenever x tending to infinity, whenever x tending to infinity, this tending to 0, this tending to 0. So overall it tending to minus 1, right? Now we'll see that. So the graph is decreasing function. So I am drawing the graph. So the graph is decreasing function means like this, and the line, this line is y is equal to minus 1. So and x is equal to 0, it is 1 clearly. So the graph of the f of x will be like this. Like this. This is the graph. So whenever extending to infinity, f of x tending to minus 1. F of x tending to minus 1. So now we can see clearly this is x-axis, minus infinity to plus infinity. So there are how many times it's intersecting? It's intersecting at only one time. So it is intersecting at only one time. So this is intersecting at only one time. So there is only one solution, right? So f of x is strictly decreasing function, correct? Next one is the equation f of x equal to 0 has exactly one solution. A and D is the right answer for this question. Very simple question based on multiple correct answer type. Clear? Now we will see the next question. So they given here ax square plus bx plus c, a positive, f of 2 minus x, f of 2 plus x, both are equal. Right, this is f of 2 plus x. For all x belongs to R. And f of x equal to 0 has two distinct real solutions. Now we'll draw the graph, plot the graph for this given information. Right? So what are they given? They given f of 2 plus x is equal to f of 2 minus x. That means what? The graph is symmetrical about x is equal to 2. What is this? The graph is symmetrical about the line x is equal to 2. One information. Another information, a positive. Whenever a positive, they given a quadratic equation is ax square plus bx plus c is given expression, and a is positive, and also they given that a is positive. Whenever a is positive, the graph is upward parabola. Whenever a is negative, the graph is downward parabola. And another information, it is symmetrical about the line x is equal to 2. Right? So x is equal to 2 somewhere else here. We'll take like that. Right? Now I am drawing the graph. Approximate graph. It will be like this. So it will be like this. The graph of is symmetrical about x is equal to 2. It will be like this. Symmetrical about x is equal to 2. Now it can be like this also. The graph will be like this also. It will be like this also. Right? It will be like this also. We cannot say anything. So x is equal to 2. So but it can say it is symmetrical about x is equal to 2, and you can see here x is a positive, no? So it is upward parabola, it's not downward parabola, right? Now with this help of information, you can see here clearly at least one root is positive clearly. At least one root is positive, either this case or in this case. Anyway, so in this case two roots are positive. In this case one root is negative, one root is positive. At least one root is positive, correct? Now see the f of 2 less than f of 1 less than f of 0. That means what? F of 2. So he can see here, in this case or in the previous case, you can see this is 0, this is 1, somewhere else, right? We'll take the values. This is 0 and this is 1. So these two values, you can see this is 2. So 0 less than x, 1 less than 2, clearly, right? But this is decreasing function in the interval minus infinity to 2. It is decreasing, clearly it is decreasing function, right? So minus infinity to 2, it is decreasing. So that's why what you can write here, whenever it is decreasing, function inequality will be reverse, right? So f of 0 greater than f of 1 greater than f of 2. Since, what you can write, since f of x is decreasing in the interval minus infinity to 2, right? In this interval it is decreasing clearly. Now we'll see the next one. Minimum value of f of x is negative. Minimum value of f of x is negative. Yes, it is negative. It lies in the fourth quadrant. This is the vertex. The vertex has the two values, 2, and this is b square minus 4ac by b square minus 4ac minus b square by 4a. 4ac minus b square by 4a, right? So this value is 4ac minus b square by 4a. So this value clearly, the minimum value is this, and it is occurred at x equal to 2. So yes, the point, the minimum value is negative because it lies in the fourth quadrant, right? So answer is negative, correct? Vertex of the graph of y is equal to f of x lies in the fourth quadrant, not the third quadrant. So this one is wrong, right? Understood? It's very simple question based on concept of quadratic equations, right? Now I'll see the next one. So which of the following are correct? Which of the following are correct? So here they given, between any two roots of the e power x cos x is equal to 1, there exists at least one root of tan x is equal to 1. Okay? Between any two roots of e power x sin x is equal to 1, then there exists at least one root of tan x is equal to minus 1. Okay, we'll see this. Okay, now I'll see this one. E power x cos x is equal to 1. E power x cos x is equal to 1. E power x cos x is equal to 1, let it be this is f of x. So whenever it is f of x, this must be minus 1, right? Differentiate this. E power x cos x differentiation is minus sin x. Cos x into e power x differentiation is e power x, and this differentiation is 0. Now, so equate it to 0, you will get e power x cos x minus sin x is equal to 0. See here, this cannot be 0, this should be 0. So that means what? This one. So tan x, this is cos x is equal to sin x. Whenever this is sent to that side, we'll write this properly. So cos x is equal to sin x, cos x is equal to sin x. So tan x is equal to 1, right? Tan x is equal to 1, correct? So at least one root of, so this is the concept of Rolle's theorem. Rolle's theorem. Between any two roots, right? Between any two roots, means the graph is like this. For example, the graph is like this. Between any two roots of the function, there should be at least one root of f dash of x. If there is two roots of f of x, between any two roots of f of x, there should be at least one root of f of x. At least one root of f of x, right? So with the help of that information, with the help of this first derivative, we can find that tan x is equal to 1 has at least one root is there, right? Similarly, we can find this b, c, d, right? So we'll see this one between e power x sin x minus 1, e power x sin x minus 1, e power x sin x minus 1. This is, let it be g of x. Differentiate this. E power x differentiation, e power x into sin x differentiation cos x, sin x into e power x differentiation e power x. So equated to 0, e power x taking common, whenever equated to 0, you will get, sorry, first of all write this. So equated to 0, you will get cos x is equal to minus sin x. So that means what? Tan x is equal to minus 1. Tan x is equal to minus 1. So there exists at least one root for the function tan x is equal to, one root of tan x is equal to minus 1 for this function, right? So this root is exist for this function. Understood? So similarly we can do this e power x sin x is equal to 1, right? E power minus x is equal to cos x function. For this function there exists one root, at least one root of e power x sin x is equal to 1, correct? So like this we can solve this. This is the concept of based on Rolle's theorem. Questions built based on Rolle's theorem, right? So fourth one is not correct. Only A, B, C are correct. Clear? I hope you understood all the solutions. Thank you.